Theophrastus. On Stones, preface. In spite of its fundamental importance in the history of mineral, ogi and chemical technology, no modern annotated translation of the Treatise on Stones by Theophrastus has been available to students of the history of science. Over 200 years have elapsed since the appearance of the first English translation by John Hill in 1746, and over 150 years since the publication of Hill's second edition in 1774. The first French and German versions, which are largely based on Hill's translation, are not only difficult to obtain now, but are also obsolete in many ways, especially in their scientific notes. Within the last 50 years, a French translation by F. de Milly and a German translation by K. Leitner have been published as parts of other works, but they are not accompanied by either text or commentary. We believe that the growing interest in the history of pure and applied science warrants the publication of a new and annotated English translation of this important Greek work. Such a translation is especially desirable at the present time, since few students of science are now able to acquire a reading knowledge of Greek. Even students of Greek who are unfamiliar with the peculiar style and terminology of Theophrastus may find this translation useful. The text and critical notes should also be of interest to them, and the commentary may be of value, for without some interpretation the numerous technical terms used in the treatise and the rationale of the processes described in it are not easily understood. We hope that the occasional items of miscellaneous information scattered through the work may be of some interest to students in other fields. There is ample evidence that this particular treatise has been neglected by scholars generally, and Hill's quaint prefatory remarks are nearly as applicable today as they were over 2 centuries ago. The many references to Theophrastus, and the quotations from him, so frequent in the works of all the later writers of fossils, would make one believe at first sight that nothing was more universally known or perfectly understood than the treatise before us. But when we come to inquire more strictly into the truth and examine with our own eyes what it really is that he has left us, we shall. Preface. Find that though no author is so often quoted, no author is so little understood, or indeed has been so little read. Those who are so free with his name, having given themselves generally very little trouble about his works, and only taken upon trust from one another, what we shall in most cases find, on strict inquiry, to have been originally quoted from him by Pliny. Many long delays and interruptions have occurred during the preparation of this book, and 4 authors have been engaged in its composition. In 1934, Earl R. Cayley of the Department of Chemistry at Princeton University and Shirley H. Weber of the Department of Classics began work on an annotated translation of the treatise. But for a long time circumstances prevented them from collaborating effectively. In the period between 1936 and the beginning of World War II, they lived both in Greece and in the United States, and could seldom meet to discuss the work, and though both were in the United States during most of the war, not much attention could be paid to the preparation of the book because of more pressing interests. As a consequence, the manuscript was never brought to a satisfactory state, and when Professor Weber returned to Athens at the close of the war to resume his position as librarian of the Gennadion, he decided that it would be impossible to continue as a collaborator. In the meantime, Thomas T. Redd of the School of Mines at Columbia University and John F. C. Richards of the Department of Greek and Latin began quite independently to prepare an annotated translation of the same treatise. Early in 1946, they heard that a similar enterprise had long been in progress at Princeton, and arranged to collaborate with Earl R. Cayley of the Department of Chemistry. After Professor Redd died in 1947, the present authors decided to complete the book. We hereby acknowledge our indebtedness to Professor Weber and to Professor Reed. Professor Weber gave much time and thought to problems of translation and interpretation. Some of his suggestions are incorporated in the present translation and in certain notes in the commentary. Professor Redd was planning to make his own contribution. It is greatly to be regretted that, owing to his illness, he could not use his extensive knowledge of geology and mineralogy for this purpose. Since both linguistic and scientific knowledge is required, Sixth preface, seems unlikely that a book of this kind could properly be produced in this age of specialized scholarship without collaboration. In such a book it is not easy to show the exact contribution of each collaborator, but the division of labor and responsibility was approximately as follows. John F. C. Richards collated the manuscripts and editions and prepared the critical notes to the Greek text. He is also responsible for the translation, though Earl C. R. Cayley made many suggestions, so that to some degree this translation may be considered a joint production. The introduction and the commentary were written jointly. John F. C. Richards supplied the notes of linguistic interest, but most of the material in the commentary was contributed by Earl R. Cayley. This includes the identification of precious stones and other mineral substances, the discussion of problems in the field of archaeology, chemistry, or mineralogy, and other matters of scientific or technological interest. We hereby express our sincere thanks to all those who have helped us in our task. Among those who have been especially helpful with criticisms and suggestions are Professor Gilbert Higgett of Columbia University and Professors Kenneth M. Abbott, William R. Jones, Lowell Regatz, and Everett Walters of The Ohio State University. Finally, we express our gratitude to the authorities of the Graduate School of The Ohio State University for their generosity in sponsoring the publication of this book. ERC JFCR Columbus, Ohio, September 1956. Introduction. Pliny, in his Natural History, mentions about 20 Greek writers as authorities for his chapters on precious stones and other mineral substances, but, of the works of these authors, only the brief, or fragmentary, Treatise on Stones by Theophrastus has survived to inform us in a direct way of the extent of Greek learning in this field. As the earliest known scientific work dealing expressly with minerals and artificial products derived from them, it is of unique importance in the history of mineralogy and of chemical technology. Theophrastus, the famous pupil of Aristotle, was born about 372 BC at Erissos on the island of Lesbos. He studied at Athens and became an adherent of the school of Plato, and later a friend and pupil of his master Aristotle. When Aristotle withdrew from Athens before his death in 322, he succeeded him as leader of the Peripatetic school of philosophy. He remained its spokesman and outstanding figure until his death about 287, for according to Diogenes Laertius, he died at the age of 85. Though Theophrastus is best known in literature for his characters, a work which has had considerable influence on the drama and on other branches of literature. His writings on natural science are at least of equal importance. His two great works on plants, for example, have led posterity to consider him one of the greatest botanists of all time, the founder of botanical science. Following the practice of the philosophers of his day, he was, however, a voluminous writer on a great variety of subjects. Primary propositions, problems in natural philosophy, history of astronomy, love, meteorology, epilepsy, animals, motion, laws, odors, wine and oil, proverbs, water, fire, history of geometry, sleep and dreams, virtue, inventions, music, poetry, history of divine things, politics, and heaven are only a few of the titles of the 220 works ascribed to him by Diogenes Laertius. In fact, so varied and enormous was the output of both Theophrastus and Aristotle that many treatises written by their pupils have no doubt been included under their names. But because of similarities in style and thought, such works can rightly be considered productions of the Peripatetic school, and for convenience be ascribed to the masters. The Treatise on Stones has sometimes been placed in this category, for in style it is more like a set of students' notes than a finished scientific work. Certain of its passages, such as the one in section 68 containing an illustrative story, are obvious abridgments that seem to be mere memoranda written to recall more detailed information. Hence it seems probable that the treatise, as we now have it, is only a set of notes taken down by some student while listening to lectures given by Theophrastus. It is also possible, on the basis of the same internal evidence, that we have before us the personal lecture notes of the master himself. Whether the treatise in its present form is a set of notes taken at lectures or previously written for lectures, it may safely be assumed to represent the actual views of Theophrastus, and he may reasonably be considered the real author. Internal evidence indicates that the treatise was written near the end of the 4th century BC, well within the lifetime of Theophrastus. This evidence appears in section 59 in the form of a statement about the time of the discovery by a certain Callias of a process for refining cinnabar. The validity of this evidence is discussed at length in the notes on that section of the commentary. There are comparatively few manuscripts, editions, and translations of the works of Theophrastus, and the Treatise on Stones has appeared even less often than some of his other works. Only 3 codices are known to contain it, namely, Vaticanus 1302, Vaticanus 1305, and Vaticanus Urbanus 108, and the versions differ little from each other. Moreover, only 2 of them are complete, as Vaticanus 1305 ends in the middle of section 43. According to Schneider, these codices were collated by Brandus, who found very little that would improve the text. The date of Vaticanus 1302 is disputed. De Vries and Gianelli put it as early as the 12th century, 6, but DLZ thinks that it is as late as the 14th. The other 2 manuscripts both belong to the 15th century. Heinsius claimed that he had made use of a Heidelberg manuscript, but this statement has been disputed. The first appearance of the Treatise on Stones in printed form is in the Aldine edition of the works of Aristotle and Theophrastus, published at Venice from 1495 to 1498, and reprinted there in 1552. The first Latin translation of the treatise appeared in Paris in 1578. This was the work of Turnebus, who had already published the corresponding Greek text in 1577. This was followed by the edition of Furlanus, published in 1605 at Hanover, containing the Greek text of some of the works of Theophrastus together with a Latin translation and a commentary. And in 1613, a Greek and Latin edition of his works was published by Heinsius at Leyden. This is an unsatisfactory edition which has been severely criticized by both Schneider and Wimmer. Some emendations of the text of the treatise were published by Salmasius Claude de Salmais in 1629 in his Funianac Exercitations. In 1647, Delay published at Leyden an annotated Greek and Latin edition of the Treatise on Stones. This appeared at the beginning of his work De Gemmis et Lapidibus Libri Duo, which was published as a supplement to the 3rd edition of De Boot's famous Gemma Rome et Lapidum Historia. It is not strictly an independent publication of the treatise. The first edition, in which the text appeared as a single work, as well as the first translation into any modern language and the first extensive commentary, was published by Hill in 1746 at London. It is still of considerable value for the light it throws on the state of chemical, geological, and mineralogical knowledge in the period during which it was written. Hill's work appeared in a second and final edition in 1774, largely unaltered as regards the text, translation, and commentary, but containing additional matter in the appendix and a fuller index. A French translation of Hill's English version and commentary, but without the Greek text, was published anonymously at Paris in 1754. and a similar German translation with additional notes by Baumgartner was published at Nuremberg in 1770. Another German translation by Schmieder is said to have been published at Freiburg in 1807, but this seems to be a very rare work, since no other mention of it could be found, and no copy could be located. These few works, which, with the possible exception of the last, are wholly or mostly based upon the labors of Hill, constitute the only past appearance of the Treatise on Stones as an independent publication. In the 19th century, the treatise again appears in the form of a Greek text and Latin translation, in Schneider's elaborate edition of the complete works of Theophrastus, published at Leipzig in 1818, followed by a fifth volume in 1821. In this fifth volume, Schneider was able to make use of some emendations of the text, suggested by Adorantios Korazis in his commentary on the Geography of Strabo published at Paris in 1819. The Greek text of Die Treatise also appears in the third volume of Wimmer's Tübner edition published at Leipzig in 1862. In the Diedot edition published at Paris in 1866, this Greek text of Wimmer is reproduced, and Wimmer's parallel Latin translation is given. Of these three important editions, Schneider's is the most valuable for its extensive critical notes and discussions of the readings of earlier editions. In this respect, the two editions of Wimmer are inferior, though the text of Wimmer is somewhat better, and in his Diedot edition he gives a Latin translation that is more original than the translation of Schneider, which largely follows the earlier version of Turnebus. In 1902, a French translation of the treatise was published by Melly in a collection of texts and translations of Carli works on precious stones. In the same year, Stefanidis published a valuable list of emendations in the Greek periodical Athena. These have been added to the list of variant readings in this book. Finally, in 1922, Mielleitner published a German translation, based on Wimmer's text, in an article on the history of mineralogy in ancient and medieval times. In addition to these complete publications of the treatise in one form or another, excerpts of various parts of it have been published from time to time in various languages in a number of scattered works. The most extensive publication of such excerpts is that of Lenz, who made German translations of many parts of Hill's English translation and added numerous short notes, most of them original, on the significance of the various passages and on the identification of the minerals and localities mentioned by Theophrastus. The most recent is that of Drobkin, who gives an English translation of 17 sections of the treatise. Aside from these partial translations, only a few other studies of parts of the treatise have appeared. Schwarze began a Latin commentary in 1801, and had published 7 parts by 1807. In 1896, Stefanidis published an important study of the treatise. Ruska's work, Das Steinbuch des Aristoteles, deals with a much later treatise on stones incorrectly attributed to Aristotle, but he refers to the treatise of Theophrastus in his introduction. Reference is made in the commentary to some of these translated excerpts and special studies, particularly to the interpretations advanced by their authors. The Greek text which is printed here is almost the same as the one established by Wim Cr., but a few minor changes have been made. The 3 Vatican manuscripts have been collated, as well as the editions of Aldus, Turnebus, Furlanus, Heinsius, Delea, Hill, and Schneider. All the important variations in the manuscripts and some of the conjectures made by the editors are listed in the critical notes, and the differences between this text and Wimmer's text have also been included. Though the traditional numbering of the sections of the text has been retained, some adjustments have been made in the paragraphs of the translation where the usual divisions between the sections appear to be illogical. In this translation, an attempt has been made to give a clear and simple English version, but at the same time to keep as close as possible to the actual words of the Greek text. In this respect, the translation differs from the rather free version of Hill, who reflected the spirit of his times and in many passages preferred elegance of expression to accuracy of statement. Nevertheless, because of the very compressed style of Theophrastus, certain passages in the present translation are of necessity expanded paraphrases of the Greek text. The difficult problem of the translation of the Greek names of mineral substances has been treated in the following way. Names of mineral substances, particularly those of precious stones, for which no exact English equivalent could be found, are simply transliterated, and appear in italics in the translation, and the question of their identification is discussed in the commentary. Names for which an exact English equivalent could be given are so translated and do not appear in italics. Generally, the Greek spelling of proper names has been used, but wherever the Latin or the English spelling is customary, this has been preferred. Thus, Theophrastus in Athens are written instead of Theophrastos in Athenae. It has generally been thought that the treatise is a fragment of a very much larger work. A possible explanation of the lacunae, and perhaps of the marked lack of literary style, may be found in an account given by Strabo, 21, who describes the fate of the manuscript books of Theophrastus after his death, and the later run, skillful attempts to restore them to their original state. Apart from a few obvious gaps, however, and the rather abrupt ending, there is no real evidence that the treatise in its present form is not a separate, fairly complete work. Its brevity is apparently the basis of most of the suppositions that the text as we have it is a mere fragment. But if due consideration is given to the nature of the treatise, and to the extent of ancient mineralogical knowledge as shown by other sources, it will be seen that it covers the field indicated by its title in an adequate manner, even though it may not be complete. Without being a purely descriptive or a purely philosophical work, the treatise seems to be an attempt to classify mineral substances on the basis of Aristotelian principles, and a number of specific examples are used. mainly for purposes of illustration, without any intention of giving extended descriptions. It may be inferred that Theophrastus mentions only a small proportion of the mineral products known to him and his contemporaries. For Pliny, though he draws largely from Greek authors, some older than Theophrastus, mentions about 10 times as many kinds of rocks or minerals. Those mentioned by Theophrastus appear to be introduced mainly to illustrate in a general way contrasting behavior and distinctive differences in stones and earths. And he may not have intended to catalog the numerous varieties that were known at the time. This would explain why he describes relatively few mineral substances in any detail, and why he pays so little attention to certain common and highly useful ones about which a good deal must have been known even in his day. From the historical standpoint, the treatise is of special interest because it represents, so far as we know, the first attempt to study mineral substances in a systematic way. For this purpose, Theophrastus divides them into two main classes, stones and earths, discussion of the latter being confined to the second and smaller portion of the treatise. Though few in number, the concise accounts of ancient chemical processes included in this division are of no little importance for the history of chemical technology. At first glance, the structure of the treatise may seem to be loose or even disconnected, but on closer examination, it will be readily apparent that this is not so. From the very beginning, Theophrastus proceeds in a systematic way to develop the subject under discussion, proceeding regularly from the general to the particular, foreshadowing what is to come and making easy transitions from one phase of the general subject to another. Though his whole method of treatment is logical enough, the classification or system resulting from it, being grounded upon superficial appearance and behavior, rather than upon any concept of chemical composition, necessarily has marked limitations. Nevertheless, from a scientific standpoint, this little treatise is much better than the other ancient and medieval works on minerals that are known to us. Pliny, for example, though he treats the subject far more extensively, does so in a much less critical and systematic fashion. The comparative freedom of the treatise on stones from fable and magic should be especially noted, for many of the works in this field written centuries later, particularly the medieval lapidaries, dwell largely upon the fancied magical or curative powers of precious stones. In fact, for almost 2,000 years, this treatise by Theophrastus remained the most rational and systematic attempt at a study of mineral substances.
O manuscripts. Fix 698 AD1. Codex Vaticanus Graecus, Versodo. 12th century. Codex Vaticanus Graecus, on Po. Codex Vaticanus Urbinas Graecus, 128. 5th century.
Translation, O.N. Stone S. Of the substances formed in the ground, some are made of water and some of earth. The metals obtained by mining, such as silver, gold, and so on, come from water. From earth come stones, including the more precious kinds, and also the types of earth that are unusual because of their color, smoothness, density, or any other quality. As the metals have been discussed in another place, let us now speak about the stones. In general, we must consider that all of them are formed from some pure and homogeneous matter as a result of a conflux or percolation, or because the matter has been separated in some other way, as has been explained above. For perhaps some are produced in one of these ways, and some in the other way, and others in a different manner. Hence they gain their smoothness, density, brightness, transparency, and other such qualities, and the more uniform and pure each of them is, the more do these qualities appear. In general, the qualities are produced according to the accuracy with which the stones are formed and solidified. Some things are solidified through heat, others through cold. And probably there is nothing to prevent some kinds of stones being formed by either of these two methods, although it would seem that all the types of earth are produced by fire, since things become solid or melt as a result of opposite forces. There are more peculiarities in stones, for most of the differences in the types of earth concern color, tenacity, smoothness, density, and so on, but in other respects the differences are rare. Stones, however, have these differences, and in addition there are others that depend on their power of acting on other substances, or of being subject or not subject to such action. For some can be melted and others cannot, some can be burnt and others cannot, and there are other differences of this kind. And some show a number of differences in the actual process of being set on fire and burnt, and some, like the smaragdos, can make the color of water the same as their own, whereas others can turn what is placed on them entirely into stone. Some have the power of attraction, and others can test gold and silver, such as the stone called the Heraclean, and the one called the Lydian. But the greatest and most wonderful power, if this is true, is that of stones which give birth to young. But the power of those used in manual work is better known, and is found in more varieties. For some can be carved, or turned on a lathe or sawn. There are some on which an iron tool cannot operate at all, and others on which it works badly and with difficulty. And there are several other differences in addition to these. The differences that are due to color, hardness, softness, smoothness, and other such qualities, through which stones gain their special excellence. Two are found in many varieties, and in some they occur in the whole of a district, and among such stones there are the Parian, the Pentelic, the Chion, and the Theban, and these stone quarries have become widely known. There is also the alabastrix found at Thebes in Egypt. This too can be worked in large blocks, and the stone resembling ivory which is called chernites. And they say that Darius was buried in a sarcophagus of this material. And there is the variety of poros, which is like Parian marble in color and density, but has only the lightness of ordinary poros. For this reason the Egyptians use it as a frieze in their elaborate buildings. And a dark stone is also found in the same place, which is translucent like the Chian stone. and there are several other kinds in other places. Such differences are common to many stones, as we have already said, but those that are due to the powers mentioned above are not found now in whole districts or in continuous or large masses of stone. Some stones are quite rare and small, such as the smaragdos, the sardion, the anthrax, and the sapphires, and almost all those that can reasonably be cut and used as seals. And some are discovered in other stones when these are cut up. There are a few which can be set on fire and burnt, and perhaps we should first explain the nature and extent of their differences. Some of them melt and become fluid when subjected to fire, such as those which come from mines. For when silver, copper, and iron become fluid, so does their stony matrix, either because of the moisture in the matter it contains, or because of the nature of such stones. In this way too, fire-resisting stones and millstones become fluid along with the material placed on them by those who are burning it. And some go so far as to say that all of them melt except marble, and that this burns up and lime is formed from it. But it would seem that it is going too far to say this, for there are many which break and fly into pieces as if they are fighting against being burnt, like pottery, for example. And this is natural since they have lost their moisture, for whatever can be melted must be moist and have a good deal of humidity. And they say that some stones that are exposed to the sun become completely dry, so that they are useless unless they are soaked and wetted again, and others become softer and are more easily broken. It is clear that both kinds are robbed of their moisture by the sun, but it happens that stones of solid texture become hard when they are dry, whereas those that are loose in texture, and those whose formation is of this kind, are easily broken and melted. Some of those that can be broken are like hot coals when they burn, and remain like this for some time, such as those found in the mine at Benai, which are brought down by the river, for when they are covered with charcoal they burn as long as air is blown onto them, then they die down and afterwards can be kindled again, so that they can be used for a long time, but their odor is very harsh and disagreeable. There is a stone called spinos, which was found in mines. If this is cut up and the pieces are piled in a heap, it burns when exposed to the sun, and it does this all the more if it is moistened and sprinkled with water. 14. But the Liparian stone is made porous when it is burnt, and becomes like pumice, so that both its color and density are altered, for before it has been burnt it is black, smooth, and compact. This stone is found in pumice, appearing separately in various places and not continuously, as if it were in a cell of a honeycomb. In the same way it is said that in Melos pumice is found in another kind of stone, and so the Liparian stone corresponds to this in the opposite way as it were, except that this stone is not the same as the Liparian stone. The stone which is found at Tetris in Sicily also becomes porous. This place is in the neighborhood of Lipara, and the stone is plentiful in the promontory called Arenias. Like the stone found at Benai, it releases a bituminous odor when it is burnt, and what remains after the burning is similar to burnt earth. Among the substances that are dug up because they are useful, those known simply as coals are made of earth, and they are set on fire and burnt like charcoal. They are found in Liguria, where amber also occurs, and in Elis as one goes by the mountain road to Olympia, and they are actually used by workers in metals. In the mines at Skaptile a stone was once found which was like rotten wood in appearance. Whenever oil was poured on it, it burnt, but when the oil had been used up, the stone stopped burning, as if it were itself unaffected. These are roughly the differences in the stones that burn, but there is another kind of stone which seems to be of an exactly opposite nature, since it cannot be burned. It is called anthrax, and seals are cut from it. It is red in color, and when it is held towards the sun it has the color of a burning coal. One might say that it has great value, for a very small one costs 40 pieces of gold. It is brought from Carthage and Massalia. The stone found near Miletus does not burn, it is angular, and there are hexagonal shapes on it. It is also called anthrax, and this is remarkable, for in a way the nature of adamas is similar. This power of resisting fire does not seem to be due to the absence of moisture, as is true of pumice and ashes. For these cannot be set on fire and burnt, because the moisture has been removed, and some think that pumice is formed entirely as a result of burning, with the exception of the kind that is produced from the foam of the sea. Their belief is due to observation and is based on what is produced in craters of volcanoes and also on the porous stone which changes to pumice when it is fired. And the places where it is produced seem to prove this, for pumice is found especially in places that but perhaps one kind is made in this way, and others in another way. And there are many methods of producing it, for the pumice found in Nisiro seems to consist of a kind of sand. And it is regarded as proof of this that some of the stones which are found break into pieces in one's hands and crumble into sand as it were, because they have not yet become compact and solid. People find them in groups but in small amounts, mostly about a handful in size or a little larger, whenever they scrape off the surface covering them. And the sand is very light. The kind found in Melos is all but some are produced in a stone of a different sort, as has been mentioned before. They differ from one another in color, density, and weight. They differ in color because the kind that comes from the lava stream in Sicily is black, and this stone and the Melodes differ in density and weight, for a pumice of this kind, having both weight and density, is also produced, and this is more valuable than the other in its practical use. The one that comes from the lava stream can cut better than the white kind, which is light in weight, but the kind that comes from the sea itself cuts best of all. So much for pumice, but we must consider elsewhere the causes, Paracelsus on stones, of the difference between stones that either burn or do not burn, from which we moved into this discussion. There are also other stones from which seals are cut that are remarkable, some of them only for their appearance, such as the sardian, the iaspis, and the sapphirose, and the last of these seems to be spotted with gold. But the smaragdos also has certain powers, for it makes the color of water just like its own. As we have said before, a stone of moderate size affects a small amount of the water in which it is placed, the largest kind the whole of the water, and the worst kind only the part close to it. It is also good for the eyes, and for this reason people carry seals made of it, so as to see better. But it is rare and of small size, unless we are to believe the records about the Egyptian kings, for it is said that among the gifts from the king of the Babylonians a smaragdos was once sent to them, which was 6 feet in length and 4.5 in width, and that 4 such stones are deposited as an offering in the obelisk of Zeus. These were 60 feet long, and their width was 6 feet at one end and 3 at the other. But these statements depend entirely on their writings. The largest of the stones, which many call Tano, is the one at Tyre. For there is a large slab in the temple of Heracles, unless this is a false smaragdos, for a species of that kind does exist. The stone occurs in places that are well known and easy to reach, especially in 2 of them, the copper mines of Cyprus and the island lying off Chalcedon. In the latter, exceptional stones are found. This kind is obtained by mining, like the others, and nature has produced it separately in many veins in Cyprus. They are not often found large enough for a seal, but most of them are smaller in size. For this reason the stone is used for soldering gold, since it solders like chrysocolla. And some people even suppose that its nature is the same, for they both happen to be similar in color. But chrysocolla is found in large quantities in gold mines and even more in copper mines, as in the ones near the districts. But smaragdos is rare, as we have mentioned, for it seems to be formed from iaspis. It is said that a stone was once found in Cyprus, half of which was smaragdos and half iaspis, as if it had not yet been entirely changed from the watery state. It takes some work to make it shine, for in its natural condition it is not bright. It is remarkable in its powers, and so is the lingurian, for seals are cut from this too, and it is very hard, like real stone. It has the power of attraction, just as amber has, and some say that it not only attracts straws and bits of wood, but also copper and iron, if the pieces are thin, as Diocles used to explain. It is cold and very transparent, and it is better when it comes from wild animals rather than tame ones, and from males rather than females. For there is a difference in their food, in the exercise they take or fail to take, and in general in the nature of their bodies. So that one is drier, and the other more moist. Those who are experienced find the stone by digging it up, for when the animal makes water, it conceals this by heaping earth on top. This stone needs working even more than the other kind, and since amber is also a stone, for the kind that is dug up 29 is found in Liguria, the power of attraction would belong to this too. The stone that attracts iron is the most remarkable and conspicuous example. This also is rare, and occurs in few places. This stone too should be listed as having a similar power. There are several other stones from which seals are cut, such 30% as the hyalocydes, which reflects images and is also transparent, and the anthralaion and the omphax stone. There is also rock crystal, and the amethyst. And both of them are transparent, and these two and the sardian are found when certain rocks are cut through. And there are others, as has been mentioned before, which differ from one another, though they have the same name. For one type, Theophrastus on stones, of sardian, which is translucent and of a redder color, is called the female, and the other, which is translucent and darker, is called 31 the male. And it is the same with the varieties of the lingurian, for the female is more transparent and yellow than the other. Also, one kind of fian of zero is called male and the other female, and the male is the darker of the two. The onychinon is mixed in color, with white and dark alternating. The amethyst is wine-colored. The actitef is also a beautiful stone. It comes from the river Achates in Sicily and is sold at a high price. 32 in the gold mines at Lampsakos, a wonderful stone was once found from which a seal was cut after it had been taken up to Astera, and this was then sent to the king because of its unusual nature. 33 These stones are rare as well as beautiful, but those that come from Greece are of less value, such as the anthrachon from Orchomenos in Arcadia. This is darker than the stone from Chios, and mirrors are made from it. There is also the stone from Trozen, and this is variegated with purple and white. The Corinthian stone is also variegated with the same colors, except that it is paler. 34 In general there are many stones of this kind, but the remarkable ones are rare and come from a few places only, such as Carthage, the country around Massalia, Egypt near the First Cataract, Siang 35 near the city of Elephantine, and the region called Cephalton 4. In addition, the smaragdos and the iaspis are found in Cyprus. The stones which are used for mosaics come from Bactriana near the desert. They are collected by horsemen who go out at the time of the Etesian winds. For they are visible then, since the violence of the winds disturbs the sand. But they are small in size and not large. 36 Among choice stones there is also the one called the pearl. This is translucent by nature, and valuable necklaces are made from it. It is produced in an oyster, which is similar to the pinna, except at 52 feet, that it is smaller. In size the pearl is as big as a large fisheye, and it is produced in India and certain islands in the Red Sea. These are approximately the stones that are of unusual excellence. But there are some others, such as the fossil ivory, which is variegated with white and dark markings. And there is also the stone called sapphirose, which is dark and not very different from the male kyanos, and there is the Paracelsus, which has the color of verdigris. and the hematitis also is of solid texture. It is dull in color, and in accordance with its name seems to be made of blood that has become firm and dry. The stone called xanthi is another variety, not really yellow in color but rather of a whitish tint, a color which the Dorians call xanthos. Coral, which is like a stone, is red in color and rounded like a root, and it grows in the sea, and in a way the petrified Indian reed is not very different in its nature from coral. But this is a subject for another inquiry. There are also many varieties of stones which are obtained by mining. Some of these contain gold and silver at the same time, but only the silver can be seen clearly. They are rather heavy in weight and have a strong odor. There is also natural kyanos, which contains chrysocolla, and there is another stone which is like glowing coals in color, and these stones are heavy. In general, a great many unusual types of such stones are found in mines. Some of them are of an earthy nature, such as yellow ochre and red ochre, and some are sandy, like chrysocolla and kyanos, and others are powdery, such as realgar and orpiment, and others that are like them. One could mention a number of peculiarities in such stones. Some stones also have the power of not submitting to treatment, as we have mentioned before. For example, they cannot be cut with iron tools, but only with other stones. In general, there is a great difference in the methods of working the larger stones, for some can be sawn, others can be carved, as has been stated, and others turned on a lathe, like the magnesian stone. This is unusual in its appearance, and some people are astonished at its resemblance to silver, though it is not related to it at all. And there are a larger number of stones which submit to every method of treatment. In Sifnos, there is a stone of this kind which is dug up about 3 furlongs from the sea. It is round and has the qualities of a lump of earth, and because it is soft, it can be turned on a lathe and carved. When it is heated in the fire and dipped in oil, it becomes very black and hard, and dishes for the table are made out of it. All such stones submit to the power of iron, but some stones, as we have mentioned before, can be carved with other stones, but not with iron instruments. And others can be carved with iron, but only with rather blunt tools, and are in much the same way. Cannot be cut with iron, and yet iron, which is harder than stone, cuts substances that are stronger. 40. That seems peculiar also, because whetstone wears away iron, although iron can divide the whetstone and shape it, but cannot do this to the kind of stone from which seals are made. And again, the stone with which seals are carved consists of the material from which whetstones are formed, or something like it, and the best whetstone comes from Armenia. The nature of the stone which tests gold is remarkable, for it seems to have the same power as fire, which can test gold too. On that account, some people are puzzled about this, but without good reason, for the stone does not test in the same way. Fire works by changing and altering the colors, and the stone works by friction, for it seems to have the power of picking out the essential nature of each metal. They say that a much better stone has now been found than the one used before, for this not only detects purified gold, but also gold and silver that are alloyed with copper, and it shows how much is mixed in each stator. And indications are obtained from the smallest possible weight. The smallest is the ritha greater than and after. 54. Translation. That there is the kplibus, and then the quarter obol, or tehalfobol 41, and from these weights the precise proportion is determined. All such stones are found in the river Tmolos. They are smooth 47 in nature and like pebbles, flat and not round, and in size they are twice as big as the largest pebble. The top part, which has faced the sun, differs from the lower surface in its testing power, and tests better than the other. This is because the upper surface is drier, for moisture prevents it from picking out the metal. Even in hot weather, the stone does not test so well, for then it gives out moisture which causes slipping. This happens also to other stones, including those from which statues are made, and this is supposed to be a peculiarity of the statue. Of such kinds are the special qualities and powers found in 48 stones. Earth has fewer of these, though they are more peculiar, for it is also possible for earth to be melted and softened and then hardened again. It melts along with substances which are dug up and which can be liquefied, just as stone also does. It is softened, and stones are made from it. These include the variegated ones and other composite stones, for all of these are made artificially when they are fired and softened. And if glass is also formed, as some say, from vitreous earth, this too is made by thickening. The most unusual earth is the one mixed with copper, for in addition to melting and mixing, it also has the remarkable power of improving the beauty of color. And in Cilicia there is a kind of earth which becomes sticky when it is boiled, and vines are smeared with this instead of birdlime to protect them from woodworms. It would also be possible to determine the differences that are 50% naturally adapted for causing earth to turn into stone. For those that are due to locality, which cause different kinds of savors, have their own peculiar nature, like those which affect the savors of plants, but it would be best to list them according to their colors, which painters also use. These substances, as we said in the beginning, are produced either by some conflux or by percolation. Moreover, some seem to have been set on fire and burnt, such as realgar and orpiment and others of the same kind. To put it plainly, all of these result from a dry and smoky exhalation. They are all found in silver and gold mines, and some of them in copper mines, such as orpiment, realgar, chrysophypla, red ochre, yellow ochre, and kyanos, but the last of these is seldom found and only in small quantities, whereas there are veins of some of the others, and yellow ochre is said to be found in masses. But there are all kinds of red ochre, so that painters can use it for flesh-colored pigments, and yellow ochre can take the place of orpiment, since there is no real difference in their color, though there seems to be. But in some places there are mines that even contain both red ochre and yellow ochre together, as for example in Cappadocia, and large quantities are dug up. But they say that the risk of suffocation is a serious matter for the miners, since this can happen to them quickly and takes a very short time. The best red ochre seems to be that of CEOs, for there are several kinds. One of them comes from mines, since iron mines also contain red ochre. But there is also the Lemnian kind, and the one called Sinopic. This is really Cappadocian red ochre, but it is brought down to Sinope. It is dug up by itself and there are 3 varieties of it, one very red, one light-colored, and a third whose color is midway between the others. We call this a self-sufficient kind because it does not have to be mixed, whereas the others do. It is also made by burning yellow ochre. But this is an inferior kind, and is a discovery of Kydius, for it is said that he became aware of it when an inn burnt down, as he noticed that some yellow ochre was half burnt and had become red in color. New earthen vessels are covered with clay and placed in ovens, for when the vessels become red hot, they heat the ochre, and as they become hotter in the fire, they make its color darker and more. Translation: like glowing charcoal and its origin, is itself a proof of this, for it would seem that all these substances change under the influence of fire. If it is right to consider that the red ochre made in this process is the same as the one made by nature, or very similar to it. Just as there is a natural and an artificial red ochre, so there is a 55 native hyanos and a manufactured kind, such as the one in Egypt. There are 3 kinds of kyanosi: the Egyptian, the Scythian, and the Cyprian. The Egyptian is the best for making pure pigments, the Scythian for those that are more dilute. The Egyptian variety is manufactured, and those who write the history of the kings of Egypt state which king it was who first made fused kyanos in imitation of the natural kind. And they add that kyanos was sent as tribute from Phoenicia and as gifts from other quarters, and some of it was natural, and some had been produced by fire. Those who grind coloring materials say that kyanos itself makes 4 colors. The first is formed of the finest particles and is very pale, 4, and the second consists of the largest ones and is very dark. These are prepared artificially, and so is white lead. Lead about the size of a brick is placed in jars over vinegar, 56, and when this acquires a thick mass, which it generally does in 10 days, then the jars are opened, and a kind of mold is scraped off the lead, and this is done again until it is all used up. The part that is scraped off is ground in a mortar and decanted frequently, and what is finally left at the bottom is white lead. Verdigris is made in much the same way. Red copper is placed 57 over grape residues 4, and the matter that collects on it is scraped off, for it is verdigris that appears there. There is also a natural and a prepared kind of cinnabar. The 58 cinnabar in Iberia, which is very hard and stony, is natural, and so is the kind found in Colchis. They say that this is found on cliffs and is brought down by arrows that are shot at it. The prepared kind comes from one place only, a little above Ephesus. It is a sand that shines brightly and resembles scarlet dye. This is collected and ground in stone vessels until it is as fine as possible. Then it is washed in copper ones. 4 trillions and what remains is taken and ground again and then washed. Skill is needed for this process, for some people make a great deal and others little or nothing out of an equal amount of sand. The washing is done from the top and separate portions are wetted one after the other. What is left at the bottom is cinnabar, and the washings are what remains above in larger quantities. They say that Callias, an Athenian from the silver mines, discovered and demonstrated the method of preparation, forethinking that the sand contained gold because it shone brightly. He collected it and worked on it. But when he saw that it did not contain any gold, he admired the beauty of the sand because of its color, and so discovered this method of preparation. This did not happen long ago, but about 90 years before Praxibulus was archon at Athens. It is clear from these facts that art imitates nature and creates its own peculiar products, some of them for use, and some only for show, such as paints, and others for both purposes equally, such as quicksilver, for this has its use too. It is made when cinnabar mixed with vinegar is ground in a copper vessel with a pestle made of copper, and perhaps several other things of this kind could be discovered. Among the substances obtained by mining there still remain those that are found in earth pits. These are caused, as we said in the beginning, from some conflux and separation of matter which is purer and more uniform than that of the other kinds. And all sorts of colors are obtained from them owing to the differences of the matter they contain. Some of them are softened, and others are ground and melted, and in this way the stones that are brought from Asia are constructed. The natural kinds of earth which are useful as well as superior in quality are 3 or 4 in number: the Melian, the Cimolian, the Samian, and a 4th in addition to these, the Tymphiac or gypsos. Painters use only Themelian kind. They do not use the Samian, even though it is beautiful, because it is greasy, dense, and smooth. For the kind which is, and is not greasy is more suitable for painting, and the Melian kind has this quality. In Melos and Samos, there are additional differences in the earth. It is not possible to stand upright while digging in the pits of Samos, but a man has to lie on his back or his side. The vein stretches for a long way and is about 2 feet in height, though much greater in depth. It is surrounded on both sides by stones, and is taken out from the space between them. It has a stratum right through the middle, and this is better than the parts on the outside. And then it has another stratum, and still another up to 4. The innermost earth is called the star. This earth is used mainly or solely for clothes. The Tymphiac earth is also used for clothes and is called gypsos. by the people who live near Mount Athos and those districts. Gypsos occurs in large quantities in Cyprus and can easily be seen, for only a little soil is removed when it is dug up. In Phoenicia and Syria, it is made by burning stones, and this also happens in Thurioi, for a large amount is produced there. And thirdly, it occurs in Tymphaea and in Perhebia and in other places. Its nature is peculiar, for it is more like stone than earth, and the stone resembles alabastrites. It is not cut out in a large mass but in small pieces. Its stickiness and heat, when it is wet, are remarkable, for it is used on buildings and is poured around the stone or anything else of this kind that one wishes to fasten. After it has been pulverized and water has been poured on it, it is stirred with wooden sticks, for this cannot be done by hand. Because of the heat, and it is wetted immediately before it is used, for if this is done a short time before, it quickly hardens, and it is impossible to divide it. Its strength, too, is remarkable, for when the stones are broken or pulled apart, the gypsos does not become loose, and often part of a structure falls down and is taken away, while the part hanging up above remains there, held together by the binding force. And it can even be removed and calcined and made fit for use again and again. In Cyprus and in Phoenicia, it is used mainly for these purposes, but in Italy it is also used for treating wine. And painters employ it for some parts of their art, and so do fullers, who sprinkle it on clothes. It seems to be far superior to other earths for taking impressions, and is generally used for this purpose, especially in Greece, owing to its stickiness and smoothness. Its powers are seen in these and similar uses, but its nature is such that it seems, as it were, to contain the qualities both of lime and of earth, namely, heat and stickiness, or rather each of these in a marked degree. It is also clear from the following example that it has a fiery nature, for once a ship loaded with clothes was itself burnt when the clothes became wet and caught fire. Gypsos is also burnt in Phoenicia and in Syria, where it is fired in a furnace. Marbles especially are burnt, and also the more ordinary kinds of stones. While cow manure is placed alongside the hardest ones 54 to make them burn better and more quickly. It seems to become extremely hot when it has been set on fire, and stays hot for a very long time, and when it has been calcined, it is pulverized like ashes. From this it seems clear that its nature is entirely due to fire. 6.0. Commentary. Commentary. 1. The metals obtained by mining, such as silver, gold, and so on, come from water. In general, the ideas of Theophrastus on the origin and nature of mineral substances are based on those of his predecessors and teachers Plato and Aristotle. His brief statement about the formation of metals from water appears to be taken directly from Plato, who believed that there were two primary types of substances having the nature of water. One of these was the liquid kind of water, which included any material that normally existed as a flowing liquid. And the other was the fusible kind of water, which included substances, such as metals, that could be made to flow by the action of heat. Plato describes the nature and formation of gold as follows. Of all the substances which we have ranked as fusible kinds of water, that which is densest is formed of the finest and most uniform particles. This is a unique kind, tinged with a glittering and yellow color, that most precious of possessions known as gold, which has filtered through rocks and there congealed. The ideas of Aristotle on the origin of metals are somewhat more complex. According to him, the metals originated from the imprisonment of vaporous exhalations in the earth, particularly in stones, where they were congealed by some sort of drying process. And as a result, a metallic substance was generated. Since it was supposed that this process was similar to the freezing of water, the metals were considered by analogy to be water, but only in a certain sense. Aristotle believed that metals consisted of matter which might have become water but could no longer do so. He did not consider them as originating from qualitative changes in actual water. On the whole, so far as we can judge from his meager statements here, the ideas of Theophrastus on the origin of metals were in somewhat closer agreement with the ideas of Plato than with those of his immediate predecessor. The statements of Theophrastus in this first section of the treatise also indicate that he was more inclined to follow the theories. 3 Meteorologica, 2, 6. 1 Timaeus, 58d, 2 Timaeus, 59 billions, 63. Of Plato on the origin of non-metallic mineral substances than those of Aristotle. Plato believed that ordinary stone was formed when, in a mixture of earth and water, the latter changed to a form of air and rose to its own region. In doing so, it gave a thrust to the surrounding air, which reacted on the remaining earth and compacted it into stone. He also thought, however, that certain kinds of stones were composed of a combination of earth and water, and this idea is accepted by Theophrastus, as shown by his statements in sections 9 and 10. But according to Aristotle, infusible stones were formed by the dry type of exhalation acting on earth, though certain fusible stones were, like the metals, more of the nature of water. 1. Stones, including the more precious kinds. The distinction here, as shown by subsequent passages, is primarily between the stones which occur in large masses in the form of rock and the various minerals of limited size and distinctive properties, particularly those that were used for seals. 1. The metals have been discussed in another place. Probably this refers to Theophrastus's lost work on mines mentioned by Diogenes Laertius. 2. As has been explained above. Though this appears to be a reference to a preceding passage that has dropped out, the close and logical development of the discussion up to this point seems to leave no room for the introduction of any other statement. Possibly this refers to a discussion in the lost treatise on mines mentioned by Diogenes Laertius, or to a passage in some other treatise that may have immediately preceded the present one in the books of Theophrastus as they were originally written. From the rather vague statements in this section, it would appear that Theophrastus was somewhat more advanced than his predecessors in his theories about the formation of mineral substances. These tended even to approach modern views on the formation of minerals by crystallization from magmatic or aqueous solutions. The more advanced nature of the views of Theophrastus is evident when his statements are compared with Plato's theories about the formation of stones and the reason for the differences in their physical properties. This is what Plato says: "But when earth is compressed by air into a mass that will not dissolve in water, it forms stone, of which the transparent sort made of uniform particles is fairer, whereas the opposite kind is coarser." 10. 3. Some things are solidified through heat, others through cold. Theophrastus seems to follow the theories of Aristotle about the solidification of mineral substances. According to Aristotle, anything capable of being solidified was either water or a mixture of water and earth, and the agent that brought this about was either heat or cold. Ordinary water and analogous substances like molten metals were solidified by cold. On the other hand, a salt solution, since it left a solid residue after being treated at an elevated temperature, was considered to be solidified by heat. Aristotle did not recognize, as we do, any radical difference in the two phenomena. Cold was supposed to act by driving off the heat, and the moisture of the liquid was believed to accompany the heat in the form of vapor. Heat was supposed to act directly in driving off the moisture and leaving the earthy or solid matter behind. In other words, solidification of substances by either agent was considered to be a drying process. Aristotle also showed that the solidification of some substances could occur in both ways. Certain mixtures of earth and water, such as common mud, were in this class, for either heat or cold could readily bring them to a solid condition. 3. It would seem that all the types of earth are produced by fire, since things become solid or melt as a result of opposite forces. The formation of ashes when materials are set on fire and burnt, and the resemblance of these to natural earthy substances, may well have been the basis of the idea that all earthy substances owed their origin to fire. In subsequent passages, Cs 50, 54, 69, Theophrastus refers again to the part that fire plays in the formation of earths, and he says more in a specific way on this subject than either Plato or Aristotle, though in his attempts to explain the process he follows closely the teachings of the latter. His statement that the solidification or melting of earths is the result of opposite forces appears to be based directly on the following theories of Aristotle. Bodies solidified by the dry hot are dissolved by water, which is the moist cold, whereas bodies solidified by cold are dissolved by fire, which is hot. For the opposite of the dry hot is the cold moist, and what the one solidify the other will dissolve, and so opposites will have opposite effects. Theophrastus means, therefore, that since all earthy substances are dissolved or dispersed by water, which is the cold moist, it necessarily follows that they must all be solidified by the opposite agent, which is fire. The dry hot. A mechanism for the softening or dispersion of earths by water is also given by Aristotle. He believed that the pores of an earthy substance were large enough to admit water particles, and that the entrance of these caused the breaking up of the solid material. Solidification came about again on the expulsion of the water particles by heat, and the earthy substance then resumed its original condition. 4. Some can make the color of water the same as their own. The manuscripts in Aldus have omuolovrai followed by the participle del top psilon mu epsilon u omicroniota, but the infinitive si omicron mu omicronio ti omicronu is expected, i.e., they are able to make the color the same. Turnipus felt the need of a main verb and changed the last syllable of shi omicron mu omicroniota konu tawalfiota. Tawakron phi alpha nu omicronu tawalfiota. Ferlanus preferred lambda gamma omicronu tawalfiota, and this was accepted by Wimmer. But it is not certain that a verb of this sort is necessary. May be that the participle svivamuevo is parallel to the participle exaut that precedes it, and the editors have not found it necessary to change this to chi omicron upsilon sigmaiota. If this is so, omicron delta is similar to above. Here oi pev is understood to correspond to oi de. Turnipus and Schneider both think that of pev should be added to the text before tk towel, but though this makes the meaning very clear, it is not essential, since moev is not always expressed. As Aovrai is not in commentary, the manuscripts and cannot be regarded as a certain emendation, it has been omitted and the last syllable of mu has been bracketed as a mistake. 4. Others can turn what is placed on them entirely into stone. The basis of this statement, which at first sight seems a mere invention, may be that a stony layer of calcium carbonate or silica is deposited by underground water on objects buried in the ground or in caves. Pliny 14 states on the authority of Mucianus that mirrors, body scrapers, clothes, and shoes buried in sarcophagi made of a certain stone are petrified. As Bailey has suggested, it is probable that these sarcophagi were made of limestone, under suitable conditions. The passage of water containing dissolved carbon dioxide through a limestone sarcophagus would dissolve calcium carbonate from its walls and deposit it on the objects inside. In a sense, then, the apparent petrifaction of these objects could be attributed to the nature of the stone from which the vessel was made. 4. Some have the power of attraction and others can test gold and silver such as the stone called the Heraclean, and the one called the Lydian. In particular, the stones having the power of attraction were Ligurian, amber, and lodestone, which are briefly described in sections 28 and 29. Heraclean stone was a common early name for native magnetic iron oxide or lodestone, and is so used, for example, by Plato. 16. The name is apparently derived from the locality where it was discovered or obtained, but it cannot now be determined with certainty whether this was the Heraclea in Pontus or in Lydia or elsewhere, though it seems very probable that it was somewhere in Asia Minor. Theophrastus apparently uses the name here to denote one kind of touchstone. Likewise, Pliny 17 mentions that a stone of this kind was called by some the Heraclean, by others the Lydian stone. It is very likely, however, that Pliny took his information from this treatise of Theophrastus, since the term Heraclean stone was sometimes used to designate the lodestone. The term Lydian stone, derived from Lydia in Asia Minor, where it was discovered or first used, was perhaps the more correct ancient name for the touchstone. Moreover, the term Lydian stone is the one that has come down into modern mineralogical literature. If, as stated by Hesychius, the Heraclean stone derived its name from Heraclea in Lydia, this may account in part for the confusion of the two names in the works of ancient writers. On the other hand, the application of both these names to the same stone in the works of the later writers may have originated entirely from the somewhat ambiguous wording of this passage in Theophrastus. It seems almost certain that Theophrastus really intended to say here that some have the power of attraction, others contest gold and silver, such as the so-called Heraclean stone and the Lydian stone respectively. The properties and uses of the touchstone are described in sections 45, 46, and 47. See also the notes on these sections in the commentary. 5. But the greatest and most wonderful power, if this is true, is that of stones which give birth to young. This curious idea seems to be the result of observing certain kinds of geode-like concretions that consist of an outer shell within which is contained a clayey, sandy, or stony nucleus. Sometimes the internal material is held so loosely that the concretion rattles when shaken. The ancients apparently believed that such stones were pregnant, and that the mineral matter on the inside was in the process of being generated. Bailey 20 thinks that the discovery of crystals with other smaller crystals attached was the origin of this idea. Though observations of such crystal growths may have contributed something to its origin, the available literary evidence gives more support to the other explanation. 18 seconds. H. Pizzella, commentary. Although Theophrastus does not name specifically any stone having this power of procreation, other ancient writers give the name eagle stone to these concretions. Pliny states that they were so named because they were found in eagles' nests, and the eagles were unable to hatch out their young without the aid of these stones. He distinguishes 4 varieties of aetites or eagle stone according to the color or consistency of the shell or nucleus of the concretion, and he names the localities where the various kinds were found. It is evident from his descriptions that such stones were often clay ironstone concretions composed of siderite native ferrous carbonate or limonite native hydrated ferric oxide, compacted with clay or sand. It is interesting to note that even in modern times the name eaglestone has been sometimes applied to such nodules of clay ironstone. However, if the accounts given by Pliny are accurate, the ancient term must have included other kinds of clay or sandy concretions. He names in addition, and sometimes describes briefly, other stones which contained embryo stones within them, such as cyatis and gassinade. He even goes so far as to declare that the period of gestation for the second of these stones was 3 months. Possibly these were different concretions, though they may have been identical with aetites. As one might expect, eagle stones were worn in ancient times as amulets to prevent miscarriage. Such stones have been worn for the same purpose in certain European countries in modern times, though Theophrastus appears to be serious in mentioning this supposed generative power of stones. His use of the phrase, "if this is true," shows that he was actually skeptical about it. Such skepticism is much less evident in the statements of the other ancient writers who touch on this subject. The word tiktovov is an emendation adopted by Schneider and Wimmer instead of tiktv, the reading of the manuscripts. What is needed is the active participle of the verb titu, to bring forth young. It seems almost certain that this verb is correct, since Theophrastus refers to a great and wonderful power, and shows that he himself is doubtful about it. Furlanus and Hesychius missed the point by changing the word to rwv, for there would be nothing wonderful about substances that could be melted. After ivwt to repeated, the word rwv appears in the manuscripts, but it is rightly bracketed by Schneider and Wimmer, since a subject in the nominative is needed and not a genitive of comparison. This subject really requires the article to introduce the words kara, tau roga malfa sig malfa. This has been understood in the translation of the passage. The power of those used in manual work is better known. And 5 has been added to the text. 6. Through which stones gain their special excellence. The manuscripts have di and v through which, before to peep silon roya tatov, but Aldus and Turnebus changed this to dio wherefore. And Furlanus suggested dia on account of, which Wimmer accepted for his text. Schneider was doubtful about the phrase sia to tepetov. It is somewhat confusing since it might mean because of their unusual nature, but qualities like hardness and softness are not unusual. However, if to reprov means that the stones have a special excellence which makes them valuable or unusual, then hardness might be appropriate as one such point of excellence. Theophrastus mentions edn teperorepa in section 1, and tau pi epsilon royo tato tanu may be a reference to this. If tau pi epsilon royo tato tanu is accepted here, There seems no reason why the manuscript reading and should be rejected in favor of the emendation of Furlanus. A relative clause meaning through which they get their excellence or from which their excellence is derived seems to be more appropriate here than a phrase meaning on account of their excellence. There is no difficulty about understanding a verb for the relative clause, and div has been restored to the text. 6. The Parian, the Pentelic, the Chian, and the Theban. It is only in this section and the next one that Theophrastus mentions the marbles and other stones used for building or statuary. He seems to regard them merely as examples of stones in which certain distinctive properties can be seen throughout large masses. The quarries on the island of Paros were celebrated in ancient times for their excellent marble. Though this is usually spoken of as Parian marble, it is also alluded to as the marble of Marpessos, from the particular mountain where the finest stone abounded. Other places on the island give evidence of ancient operations, and the stone is still available for quarrying at the present day. From a dazzling white to a creamy white in color, it had such an attractive appearance that a number of ancient authors thought it worthy of mention. This was the marble which was regarded as most suitable for statuary, and was used by many of the most celebrated sculptors of antiquity. Scarcely less famous was the Pentelic marble, so named from Mount Pentelicos near Athens. The ancient quarries were at a place called Spilia, about 12 miles northwest of the Acropolis. This stone is still quarried at the present time, and most of it is used in the construction of buildings in modern Athens. In ancient times it was widely used for architectural purposes, as is shown by the Parthenon and other surviving structures. Pentelic marble is as fine-grained as marble from Paros, but it takes on a yellow tone on weathering, and there are occasional dark streaks running through it. It was apparently less esteemed than Parian marble for the purposes of sculpture, probably because of its less uniform character, though many of the remains of ancient sculpture that have been found in Attica are of Pentelic marble. It is curious that Hill remarks in reference to this marble, T. Pentkligen, is now wholly unknown, and has been so for many ages. The earlier statement of delay, I don't remember that I have read about Pentelic marble anywhere else, also reflects the general state of ignorance in Western Europe concerning Greece under Turkish occupation. Less is known with certainty about the nature of the marbles or other stones obtained in ancient times from the island of Chios. Pliniade states that in his opinion variegated marbles were first discovered in the quarries of Chios. From another passage, where the reading is uncertain, some have inferred the Chian marble was uniformly black, though Mayhoff adopts another reading, MDO, in his edition of Pliny, and does not think this refers to Chios. Theophrastus implies in the next section that the Chian stone was black. He also says it was translucent, perhaps a reference to its surface appearance when polished. In section 33, where Theophrastus gives brief descriptions of inferior variegated dark stones used for seals, he apparently compares one of them with a stone from Chios. On the whole, it would appear that the ancient Chian quarries yielded a black or dark marble or other rock, in which there were spots or streaks of light-colored minerals. That the Theban quarries here mentioned by Theophrastus were located in the vicinity of ancient Thebes in Egypt, rather than the Greek city of Thebes in Boeotia, is almost certain. For not only does he go on immediately to name particular stones found near Thebes in Egypt, but he also says what is well known, that the ancient Egyptian locality was celebrated for its great stone quarries. If Theophrastus is referring to quarries in or near the Egyptian Thebes, then he must be speaking of the limestone still so plentiful in this pan of the Nile Valley. Even now there is evidence of the ancient workings there. If, as is more probable, Theophrastus meant to include the quarries in the general territory of Thebes, then sandstone and even granite could also be mentioned. Although the great source of granite was at Syene, modern Aswan, about 100 miles or so south of the city of Thebes, it is perhaps significant that the Theban stone which Pliny 0 mentions was apparently a granite. 6. Alabastrix. This was well known in ancient times, as is attested by numerous references to it in the works of early writers. Judging from the description given by Pliny, this stone was in all probability compact stalagmitic calcium carbonate, the onyx marble of Egypt, sometimes called oriental alabaster to distinguish it from true alabaster, which is similar in appearance but is actually a compact variety of gypsum, a hydrated calcium sulfate. Even today, this particular onyx marble is often loosely called alabaster. It is a beautiful white or yellowish white stone, slightly translucent and frequently, though not always, traversed by bands of slightly differing shades. That this stone was extensively quarried in ancient Egypt is amply shown by the traces of the former workings, as well as by the numerous objects composed of it that have survived, such as vases, statues, and even parts of buildings. However, here again it must be understood that Theophrastus is speaking in a vague general way of the territory of Thebes, for the nearest source of onyx marble appears to be considerably more than 100 miles north of the site of the ancient city of Thebes. The ancient workings are still to be seen today, and the principal ones extend from Minia to Asyut. 6. Yhtronites. This passage contains the only information we have about the nature of this stone. Pliny mentions it but merely paraphrases the statement of Theophrastus. Hill 84 identified it as a white marble, though he did not explain his reasons. Against this identification is the fact that native marble was scarce and relatively little used in ancient Egypt. Furthermore, the few objects made of this stone that have been found are generally very small, by no means approaching a sarcophagus in size. Moore identified churnites as true alabaster. The context suggests that it was either alabaster or a particular variety of Egyptian onyx marble, for Theophrastus commonly groups together mineral substances similar in nature or appearance. but it is not very likely that it was a true alabaster. Such compact gypsum was scarce and little used in ancient Egypt. Where only a few small objects made of it have been found, it appears more probable that it was a particular kind of onyx marble, possibly a white, more uniform variety. As contrasted with the common variety that was yellowish and banded, Theophrastus mentions particularly that a sarcophagus was made of chernites, and several such Egyptian burial objects composed of onyx marble have survived to our day. 7. Poros. The usual spelling is pi, not pi. Other Greek authors mention poros or poros stone, and their statements, together with the evidence of geological formations and our knowledge of the stones used in ancient structures, show that these terms were general ones that were applied to rocks of cellular structure and low densities such as calcareous, tufa, or fossiliferous limestone. The statement of Theophrastus here is somewhat reminiscent of the one made by Herodotus, who remarks, in speaking of the building of the Temple of Apollo at Delphi, that the front was of Parian marble and the main part of poros stone, which in this case was the calcareous tufa plentiful around Mount Parnassus. Pausanias states that the Temple of Zeus at Olympia was made of poros locally obtained, undoubtedly the coarse fossiliferous limestone of that particular locality. In general, such limestone rock, being plentiful in Greece and easy to quarry or work, seems to have been a favored building material, as is shown by its presence in a number of surviving ancient structures or ruins. The kind of poros which Theophrastus compares with Parian marble might be identified as travertine, a stone which in general appearance as well as chemical composition is very much like marble. There is ample evidence that travertine was widely used for building purposes in ancient times, particularly in Italy, and surviving examples show that fine-grained calcareous tufa or travertine was also frequently employed for statuary. But when the name poros is applied to a marble-like stone used by the Egyptians for elaborate buildings, it probably has a special meaning. It seems to mean some variety of Egyptian onyx marble, as this is the only marble-like stone that the Egyptians used in the construction of buildings. It was especially used in the construction of sanctuaries and temples, as is shown by surviving examples that have come down to us. Though Theophrastus apparently speaks of onyx marble as alabasterites or chernites in the preceding section, it does not follow that this identification is wrong, since the stone occurs in several varieties that differ much in appearance. Moreover, the ancients often gave different names to the same mineral substance, or used the same name to denote two or more mineral species that we consider entirely distinct. The latter practice seems to have been true of poros, as it is very probable that this term included not only calcareous tufa and fossiliferous limestone, but also certain other soft rock suitable for building purposes. The loose usage of the term poros by ancient authors, and the equally broad interpretation of its meaning by modern archaeologists, has been pointed out by Fraser. Eichholz rightly thinks that this poros must have been a special kind found in Egypt which had the lightness of the ordinary Greek poros but was not the same. This explains the difficulty in the text, which appears to say that poros has the lightness of poros. 7. And a daryl stone is also found in the same place, which is translucent lie the Chian stone. Unless more than a word or two is dropped out between this and the preceding phrase, the reference is apparently to a dark or black stone found in Egypt which, at first sight, one might be inclined to identify as obsidian, since this is the only dark or black stone that exhibits any marked degree of translucency. Hill believed that the stone was obsidian, but this identification is unlikely since obsidian is not native to Egypt, although small amounts evidently were imported in ancient times to make ornamental objects, such as amulets and vases. However, several kinds of dark gray or nearly black stones were quarried there, as is shown by existing remains. The dark granite found at Aswan, for example, was used to some extent in the construction of buildings. Since Theophrastus is dealing in this section with stones found in large masses, this might well have been the stone described here, though granite is certainly not translucent, unless the allusion is to the surface appearance of the polished stone. Basalt and diorite were also quarried in ancient Egypt. In addition, the Egyptians used a particular kind of diorite gneiss, a banded or mottled black and yellowish white rock, and also a black and white porphyry composed of white crystals embedded in a black matrix. On the whole, it seems likely that Theophrastus is alluding to one of these last two stones, especially since he compares the variety that he mentions with the Chian marble or stone, which, as indicated by the note on the preceding section, was probably a black rock variegated with spots or streaks of light-colored material. 8. Almost all those that can reasonably be cut and used as seals. The reading of the manuscripts, Zedov, Oyov, makes no sense. The meaning seems to be almost all of those which, and this could be represented by nu tau or here tanu is added to go with tanu, but this does not account for the presence of. Delact and Hill changed this to, but the meaning of this is not clear.
Snyder thought that the verb katalegode might have survived as logon, and proposed σχεδεν esi katalegode estes phragidia ten glypton. The phrase karal lambda oyov, according to reason, reasonably is attractive, and Stefanidis rightly included it in his emendation, sigma shipsilon delta ono, piano tau epsilon somikrone kappa alpha tau lambda omikrono. Epsilon destaue sigma firu alpha gamma delta alpha gamma lambda epsilon pita omikrone. Though it is impossible to know what was originally in the manuscripts, the emendation tautis to kata seems to be a good one and has therefore been added to the text. These three words are of the right length to fill up the gap in the Aldine edition, but this does not confirm their accuracy, for the gaps are of different sizes in the manuscripts.
In A there is room for only a few letters, the space in both and C is longer but not long enough, so nothing can be proved by the size of the gaps. 8. And some were discovered in other stones when these are cut up. This apparently refers to crystals lining rock cavities or geodes, and especially to crystalline quartz which so commonly occurs in this manner. Since in section 30 it is specifically stated that rock crystal and amethyst are found by dividing other stones. 9. Fire-resisting stones and millstones. Aristotle refers to these two kinds of stones in a similar way, except that he implies that they were fusible by themselves, whereas 48 Meteorologica. Theophrastus states here that they were fusible when placed in contact with certain other material. Since the two kinds of stones are mentioned together, it is likely that they were either similar in nature or had some common property or use. Though there is no direct evidence that would enable us to identify the first of these two classes of stones, several references in ancient literature make it possible to identify at least some of the class of millstones. Strabo, for example, observes that the lava of Etna becomes millstone on cooling, and in another place 44 he mentions that an abundance of millstone was found on the volcanic island of Nisyros. Pliny, on the other hand, states that a superior kind of quicklime was prepared from the stone commonly used for millstones, malaris. Although it is very likely that a variety of stones were used for millstones in ancient times, the remarks of these authors indicate that they were usually made either from highly siliceous volcanic rocks or from common hard, compact limestone. From the name it may be inferred that fire-resisting stones were varieties of limestone, and since Aristotle 50 mentions the fusibility of such stones immediately after referring to the manufacture of iron, this identification is even more likely, for limestone is generally added as an essential fluxing agent in the smelting of iron ore. Although there is no necessary connection between the sentence in Theophrastus dealing with these two stones and the two preceding sentences, it seems quite likely that such a connection was intended. If the passage is understood in this manner, then it also seems justifiable to assume that, because of the chemical nature of the two kinds of stones, the material that was burnt with them was the mixture of ore and fuel used in making up the charge for the smelting furnaces. For these two kinds of stones supply the two different types of fluxes needed for the reduction of ores, the acid type in the form of highly siliceous rocks, and the usual basic type in the form of limestone. Though they lack precision, the brief allusions to ore smelting in this section of Theophrastus are of considerable interest, since they are the earliest historical reference to the process. 9. Become fluid along with the material. Some preposition like ov with is missing in the Greek text. Either omicron upsilon sigma nu omicron omicroniota sigma omicronu might be expected. 9. And some go so far as to say that all of them melt, except marble, and that this burns up and lime is formed from it. Though covia has been translated as lime, an alternate possibility is ashes. This meaning is discussed in the notes on section 69. In that section, Theophrastus describes briefly the burning of marble in order to make lime. He is essentially correct in noting the infusibility of marble, for most rocks being composed of silica, silicates, or various mixtures of the two, melt at moderately elevated temperatures, but marble, which is a rock, composed of nearly pure calcium carbonate, decomposes without melting at temperatures near 900 degrees Celsius, under ordinary atmospheric pressure. The residue, which is calcium oxide, is itself a very refractory substance that melts at about 2,570 degrees Celsius, when it is pure. But this temperature was not available to the ancients, and is not reached in modern furnaces operating on ordinary fuels. Modern investigators have found, however, that calcium carbonate, either in the form of the pure compound or in the form of marble, does melt when both the temperature and the pressure are high. Enough. 10. There are many which break and fly into pieces. Theophrastus means here that some stones are infusible because, like earthenware, they contain little or no moisture. According to Plato, the brittleness of earthenware is due to its mode of formation, for earthenware, like stone, is formed by the expulsion of water from a mixture of water and earth, followed by compression of the mass by the reaction of the surrounding air. However, in the formation of earthenware, the mixture was thought to be so rapidly deprived of its water by the action of fire that the sudden violence of the compression made the product harder and more brittle than stone. Plato also attempted to explain why an admixture of some water with earth was necessary in order to produce a material fusible by fire. He considered that if a body were composed of earth alone, not compacted by any unusual force, the interstices in it would be larger than the fire particles, which could therefore pass in freely without exerting any force that would tend to break up the mass. On the other hand, he considered that if some water were present, the fire particles could force their way into the smaller pores of the water particles, and thus break up or disturb these. And they in turn then acted on the earth, so that the entire mass was broken up and fusion was finally effected. But Plato believed that when the mass of earth was forcibly compacted, as was supposed to happen to earthenware, the pores were smaller, and only fire particles could find an entrance. Theophrastus seems to imply here, as a logical extension of this argument, that the reason pottery and certain stones fly apart on the application of heat is that the fire particles force their way into the small pores of such bodies, which are thereby fractured owing to their inherent brittlings. The negative should be bracketed in the text. The meaning ought to be that many stones, like pottery, fly into pieces owing to the action of fire. It seems most unlikely that Theophrastus intended to make an exception of pottery. 11. They are useless unless they are wetted again. It is not obvious why the denser stones which harden on drying are supposed to become useless. Possibly the allusion is to their availability for cutting or carving, for some absorbent stones are definitely easier to work when wet. With sandstone, for example, this is certainly true, for it is cut much more easily when it is impregnated with water, as it often is in the quarries, than when it is completely dry. The statement that certain stones become softer and more brittle when they are dry is also somewhat obscure. There is a strong probability that the allusion is to native asphalt and related substances, which were well known and extensively used in ancient times. These soften in a Schureristic way when subjected to moderate heat, and this would happen if they were exposed to the sun. This interpretation seems likely, since Theophrastus goes on immediately to discuss various brittle stones which were obviously natural bituminous substances. 12. Some of those that can be broken are like hot coals when they burn, and remain like this for some time, such as those found in the mine at Benae, which are brought down by the river. Bina was a town in Thrace, but its exact location is unknown. Theophrastus uses the plural form Benae. The account given by the writers of the Etymologicum Magnum, namely that the place received its name because of the immorality of its inhabitants Bevelv, is obviously false. Procopius mentions a castle Bivios in a list of forts, and this may have been at the place in question. Stephanus of Byzantium lists Bena as a city of Thrace, and states that the spelling was sometimes Bena or Bena, though the former was better. At the time when Stephanus lived, Bena and Bina would have had the same pronunciation, so that it seems likely that this was the place which Theophrastus mentions here. Unfortunately, Stephanus too fails to locate the city. That it was probably on a Thracian river named Pontus is indicated by a passage in the pseudo-Aristotelian work De Mirabilibus Auscultationibus. The allusion here is undoubtedly to some sort of natural solid bituminous substance, though the description is not adequate for an exact identification. The fact that the stones are described as brittle would suggest a bitumen associated with shale or soft limestone. The most likely identification is rock asphalt, for the combustible stone of Irenaeus mentioned in section 15 was probably rock asphalt too, and this is said to be like the kind found at Bina. The material called spinos, mentioned in the next section, was probably a solid bitumen, and this also suggests that the stones found at Bina were asphaltic in nature. The only objection to such an identification is that bitumens are not of frequent occurrence within the boundaries of ancient Thrace. There is a possibility that the stones found at Bina were lignite, or some related non-asphaltic pyrobitumen, though the fact that Theophrastus mentions lignite separately in section 16 makes this identification somewhat unlikely. 13. Spinos. The only other ancient work in which this mineral substance is named seems to be the De Mirabilibus Auscultationibus. Here it is briefly mentioned in two separate passages. The passage in section 33 may be translated as follows: "And in Thracian Bithynia the so-called spinos is found in mines, and they say that fire is kindled from it." And section 41 states that spinos burns when it is cut up and put together again and sprinkled with water. Since Bithynia was the name of a province in Asia Minor, it might seem that a geographical contradiction exists in the first of these two passages. But it is clear from an account of Strabo that there were Bithynians living in Thrace, and in fact the inhabitants of the province of Bithynia originally came from Thrace to Asia Minor. Both these passages show, therefore, that spinos was a combustible mineral substance found in Thrace. The behavior of spinos when moistened with water suggests that it was the same mineral substance as the Thracian stone mentioned by various ancient authors, such as Nicander Dioscorides and Pliny. Hence, spinos appears to have been an early name for Thracian stone, though it is impossible to identify it with any degree of exactness. Spinos or Thracian stone was probably some kind of asphaltic bitumen. Some have suggested that Thracian stone was lignite or brown coal, and others have identified it as ordinary bituminous coal, or, in an attempt to account for its peculiar behavior with water, as coal containing pyrite. The conjecture of Stephanides 65 that it was an asphaltic lignite is probably nearer the truth. It is not improbable that spinos and the combustible stones found at Bina were merely varieties of the same mineral substance, different perhaps in respect to asphalt content, or possibly only in superficial appearance. That the ancients confused the various sorts of solid natural bitumens is fairly certain. Even in modern times their classification has been a difficult problem. The origin of the word spinos is obscure, and even the quantity of the first vowel is uncertain. It seems better to write pi in the text, following Becker in his edition of Aristotle, rather than which Wimmer prefers. 13. In mines. The actual reading of the manuscripts is ev mu, in the mines, but Wimmer changed this to mu shot 5, in the same mines, meaning the mine at Bina mentioned in section 12. This emendation is supported by the passage in DC Mirabilibus Auscultationibus, which states that spinos was found in mines in a certain part of Thrace, by the fact that Bina was located in Thrace, and by the apparent similarity of spinos and the stones found at Bina. Nevertheless, it by no means follows that spinos was mined at Bina, and Wimmer's emendation has not been adopted. 13. This is cut up and the pieces are piled in a heap. It burns when exposed to the sun, and it does this all the more if it is moistened and sprinkled with water. This statement probably describes the spontaneous combustion of a pile of bituminous material. Dry piles of such materials often ignite spontaneously under the proper conditions, as has been observed repeatedly with unventilated piles of ordinary coal. The last part of this statement, which is probably based on uncritical Observation describes the effect of throwing water on a pile of smoldering bituminous material. The clouds of smoke and steam are regarded as a sign of increased combustion. All the other ancient writers who described the Thracian stone, some of whom certainly made use of this passage in Theophrastus, entirely misunderstood the reasons for its combustion, as is evident from their commentary accounts. Nicander states that Thracian stone flames up when it is moistened with water and is quenched by oil. Dioscorides increases the marvelous nature of the phenomenon by stating that the stone was ignited by water and quenched by oil. Pliny discusses the heat that is developed when water is added to Thracian stone, which he compares with lime, and also says that it could be quenched with oil. Evidently, the story increased with the telling. Theophrastus was apparently the first to mention spontaneous combustion. Moreover, he seems to have been the only ancient writer to allude to this phenomenon in a reasonably clear and rational manner. 14. Liparian stone. This was evidently named from the volcanic group called at present the Lipari Islands, lying off the northeastern coast of Sicily. These islands are still the scene of much volcanic activity. The locality and the description leave little doubt that this so-called Liparian stone was what we now call obsidian. Large quantities of this dark volcanic glass occur at certain places on these islands. The mention of pumice in connection with the Liparian stones supports the identification, for both these varieties of glassy rhyolite or liparite commonly occur together, often in the very way described by Theophrastus. Stephanides, on the basis of a very literal interpretation of the statements in this section, identified this Liparian stone as a combustible mineral substance, possibly a volcanic rock impregnated with asphalt. But it is clear from what Theophrastus says in sections 19 and 20 about the creation of pumice by fire that combustion in the modern sense of the word is not to be understood here. The ancients apparently made little or no distinction between actual burning and the phenomena connected with molten material at a high temperature. Thus, when pumice was formed by the expulsion of gases from molten volcanic glass at the time of solidification, this did not seem to differ from the combustion of a mineral substance such as lignite, especially since the end products, pumice in the one case and ash in the other, are somewhat similar in superficial appearance. Obsidian from the Lipari Islands and the neighboring volcanic regions was used from early times for ornamental and useful purposes by the peoples of the Mediterranean region, as is clearly shown by the numerous archaeological finds. Theophrastus appears to be the first writer to give a distinctive name to obsidian, though it is not improbable that the black stone mentioned by Plato was also obsidian. Pliny called it obsiana, neuter plural. This spelling appears in Mayhoff's text, but there is a variant reading, obindiana, which is the origin of the present English name. 14. Miklos. This is an island of volcanic origin in the southern Aegean, about halfway between Crete and the southern tip of Attica. In his reference to the pumice of Melos, Theophrastus seems to mean that it occurred in separated cells in the solid rock, though this was not obsidian. Probably he refers to the occurrence of pumice in ordinary rhyolite. Pumice is abundant both on the Lipari Islands and on Melos, and these localities are leading commercial sources at the present day. Theophrastus refers to pumice in more detail in sections 19, 20, 21, and 22. See also the notes to these sections. 15. Tetras. It is clear from the reference to Lipara that this was situated somewhere in the northeastern corner of Sicily. This locality is not mentioned elsewhere, though it is very brief. The statement about the stone found at Tetras shows clearly that it was some volcanic product similar to the one mentioned in the preceding section. 15. Aranias. This name is not found elsewhere. Strab mentions a town. Commentary. Aranios, which was in Doris in central Greece, but evidence for connecting it with the promontory called Aranias is lacking. Though the text does not actually say so, it seems probable that, like Tetras, this was a place in Sicily. The similarity of the stone found at Arinchus to those at Bina, the odor on burning, and the appearance of the residue after combustion, all tend to show that it was a bituminous product such as rock asphalt. The occurrence of great quantities of this material in Sicily lends considerable support to this identification. The deposit at Ragusa, for example, which forms a bed 10 to 50 feet thick and 1,600 to 2,000 feet long, is one of the largest in Europe, and, in spite of the fact that it has been worked for a long time, recently over 100,000 tons of rock asphalt have been obtained from it annually. Smaller deposits of commercial importance occur at Modica and Sagli in the same region. The rock asphalt in these localities is a soft fossiliferous limestone containing from 2 to 30% of actual asphalt. If one assumes that Arinchus was in Sicily, the combustible stone found there could not have been some non-asphaltic pyrobitumen such as coal or lignite, for these do not occur on the island. 15. The stone found at Binai. The reading Rhone and Bives is the emendation of Turnibus. The manuscripts have Reis, but this makes no sense. Binai has already been mentioned in section 12:16, among the substances that are dug up because they are useful, those known simply as coals are made of earth, and they are set on fire and burnt like charcoal. Here Theophrastus mentions Liguria, a coastal district in northwestern Italy, and Elis, the district in Greece in the northwestern part of the Peloponnesus, where Olympia is situated. Some commentators on this interesting passage have concluded that Theophrastus is referring to anthracite, or to bituminous coal. Certain considerations, however, make it very improbable that this conclusion is justified. One is that true coal does not occur in Greece, Theophrastus on Stones, and, though small deposits of anthracite are to be found in the Western Alps in the extreme north of Italy, the most abundant type of non-asphaltic pyrobitumen that is found in the region once known as Liguria is lignite. And this is also a fairly common occurrence in Greece. Some important evidence is also given by Theophrastus himself in his treatise on fire c. 75, where he explains why prepared coals, i.e. charcoal, are blacker than the kind that are dug up. This seems to indicate clearly that the latter was brown coal or lignite. The allusion in the present passage to the earthy nature of these coals leads to the same conclusion. It is interesting to note that at the present time lignite is mined on a large scale for domestic and industrial purposes in the same part of Italy. Large quantities are also mined in Greece, even though this passage does not refer to the use of true coal. It is nevertheless of historical importance as containing the earliest known account of the use of a mineral product for fuel. The use of lignite is scarcely mentioned elsewhere in ancient literature, apart from Antigonus of Carystus, who says that according to Theopompus coals were dug up for use in the neighborhood of the Thesprotians. Theophrastus appears to be the only ancient writer who touches on the subject. Hence it seems almost certain that lignite was not commonly employed in ancient times. From what Theophrastus says, it is not certain to what extent lignite was used as a general fuel, since he merely states that metal workers made use of it. They probably found it of special value for the operation of forges and furnaces. Modern writers on ancient technical processes have often assumed that wood and wood charcoal were the only fuels available and in use among the Greeks and other ancient peoples, but this passage gives unquestionable evidence of the use of mineral fuel, at least in certain industrial arts. 16. Amber. This is mentioned again in section 29, where it is said to be found in Liguria, but that is certainly incorrect. See the notes on section 29 for a discussion of this question. Commentary. 17. In the mines at Skaptile a stone was once found which was like rotten wood in appearance. Whenever oil was poured on it, it burned, but when the oil had been used up, the stone stopped burning, as if it were itself unaffected. Skaptile was a mining district in Thrace opposite the island of Thasos in the northern Aegean. According to Davies, the modern Eski Kavala is perhaps the district. In Wimmer's text, the name appears in the genitive case and is written as one word, sigma kapal fapatauatau micron lambdata, but the true nominative form is sigma kapal fapatau lambdata, a forest that may be dug. In the manuscripts, the name appears as two words, iamris vns, and the first includes the preposition ev. Turnebus changed this to nu sigma kapal fapataue to sigma lambdata. The Latin name is Scaptensula, but Scaptensula is the spelling found in Lucretius. Something seems to be lacking in this passage. Does Theophrastus mean that the stone became ignited as soon as oil was poured upon it, or does he mean that when oil was poured upon the stone and ignited, it then burnt away, leaving the stone in its original state? The second meaning certainly seems more probable, though the first one may well have been what Theophrastus intended. For when ancient authors say that Thracian stone and other combustible mineral substances are ignited by water and extinguished by oil, they seem to regard this as a phenomenon worthy of special mention, because it is opposed to the normal order of things. It is untrue, however, that any mineral can be ignited by the mere act of pouring oil upon it. If such a notion was held by Theophrastus and other ancient writers, it probably originated from distorted hearsay evidence or from false reasoning divorced from experience. More thought that Theophrastus was really referring to asbestos. The color of the stone makes this unlikely, though its structure makes it less improbable, since some forms of decayed wood do have a fibrous structure like asbestos. We know from statements of various early authors that asbestos was known in antiquity, and that it was mainly used for the manufacture of incombustible cloth, though evidently wicks for oil lamps were also made of it. Moreover, direct evidence of the use of asbestos by the ancients has been obtained in modern times by the discovery of ancient garments woven from this mineral. It is, however, unlikely that Theophrastus is alluding to asbestos, since the mineral does not occur in the locality mentioned. There were only two known sources of asbestos in Greece and its vicinity in ancient times, Charistos at the southern extremity of the island of Euboea, and a place to the southeast of Mount Troodos on Cyprus, where the abandoned workings are still to be seen today. It is much more probable that Theophrastus is referring to the well-known brown fibrous lignite, which in appearance and in other respects very often closely resembles rotten wood. Lignite of various kinds is known to occur in the region named by Theophrastus. He seems to be pointing out that when oil is poured on this material and ignited, the oil burns away without igniting the material, though this would be combustible under the proper conditions. Lignite of the kind to which he apparently refers often contains in its natural state as much as 20% of water. Thus, it cannot readily be ignited, though it is combustible when it is properly dried out, and this soon happens if, for example, it is placed on a bed of glowing coals. As Theophrastus shows in the last sentence of this section, he is dealing here, and in most of the preceding sections of this chapter, with mineral substances that are actually combustible. The discussion of incombustible minerals is taken up in the next chapter, and, if the interpretation of this passage is correct, his description of a combustible mineral substance which under certain conditions is incombustible affords a logical transition to his next general topic. Indeed, since Theophrastus in other places in this treatise makes similar transitions, this peculiarity of his style might possibly be taken as additional evidence in support of this identification. 17. Whenever oil was poured on it, it burnt. In this passage, the optatives pi and which are used with or are followed by verbs in the present tense instead of the imperfect, which would be usual. The manuscripts have, which Aldous changed to, and ira vari. It would be possible to amend the text and to read in Svavkro. But it is not certain that Theophrastus would have felt obliged to follow the strict sequence of tenses. It is, however, necessary to translate as it burnt rather than it burns. It seems better to restore the reading of the manuscripts, especially since follows here Wimmer has taken the reading of Aldous. 18. Anthrax. This appears to have meant originally a glowing live coal. The word was used later, as Theophrastus uses it here, to mean a transparent precious stone of a deep red color. It appears to have been first used as the name of a gem by Aristotle, who says that the seal stone called anthrax is the least affected by fire of all the stones. Theophrastus, however, is the first to give descriptive details by which the stone can be identified. Though anthrax was probably a generic term that could have been applied equally well to the ruby, red spinel, or red garnet, it is fairly certain from the evidence available that the stone designated by this name was nearly always red garnet at the time of Theophrastus. In the first place, no engraved rubies or spinels dating from the Hellenistic period are known with certainty, whereas many engraved garnets have come down to us and exist today in various museums. In the second place, the ruby, with its high degree of hardness, could not normally have been used for seals by the Greeks, since they would have experienced great difficulty in engraving this stone with the abrasives then available. Garnet, on the other hand, with its lower degree of hardness, offered no such technical difficulty. It is worth noting that when Theophrastus begins to discuss incombustible stones, he mentions a variety which seems to be related to combustible stones by its name and appearance, and thus he makes an easy and not illogical transition from one class to the other. It is clear from the brief remark of Aristotle quoted in the preceding paragraph that Theophrastus was not the first to notice that anthrax could not be burnt. It is easy to understand why philosophers of the peripatetic school would emphasize the paradox involved in a stone, which, though connected with fire by its name and appearance, was itself incombustible. As a matter of fact, garnet, though quite incombustible, is more readily changed by fire, owing to its lower melting point, than the different varieties of quartz from which most of the seals were made at the time of Theophrastus. 18. One might say that it has great value, for a very small one cost 40 pieces of gold. Probably the reference is to gold staters of Alexander III or his father Philip II of Macedon, which were in common use at the time. Each of them weighed about 8.6 grams, but had a much greater purchasing power than modern coins of the same precious metal content. King thought that in an age of extended commerce, such a high price could scarcely have been paid for a stone as common as garnet. And it was largely because of this that he identified this first anthrax, mentioned by Theophrastus as the ruby. However, engraved garnets first appeared in the Hellenistic period, as is shown by the surviving examples. Possibly they were introduced during the lifetime of Theophrastus, and since they may have been a scarce and highly prized novelty at the time of their introduction, the price mentioned does not seem excessive. Furthermore, flawless garnets of brilliant red color are much scarcer than good specimens of the various kinds of quartz that the ancient Greeks valued highly as precious stones. It should not be forgotten that stones which were highly prized by the ancients, although apparently very costly at the time, would not usually be termed precious today. Most of them would be rated as semi-precious, or even less valuable stones. 18. Carthage and Massalia. Since Carthage in North Africa and Massalia at the site of modern Marseille were both important seaports, it must be understood that these were merely points of export, not the localities where the garnets were found. Corre suggested that Malvias, a district in the country behind Carthage, should be the correct reading here. Though it is true that Strabo mentions only localities in North Africa as western sources of these precious stones, the more comprehensive list of Pliny includes Massilia Marseilles and Olisipo Lisbon as well. Theophrastus mentions Massalia again in section 34 as a place from which precious stones were obtained. On the whole, the conjecture of Corres is not plausible enough to justify an alteration of the text. 19. The stone found near Miletus does not burn. It is angular and there are hexagonal shapes on it. It is also called anthrax, and this is remarkable, for in a way the nature of adamas is similar. The kind of anthrax found near Miletus on the western coast of Asia Minor evidently had a striking and peculiar form. Theophrastus appears to be speaking of a well-crystallized mineral with hexagonal facets. It is significant that both garnet and spinel often occur crystallized in this manner. Of the two, spinel seems more likely, since the anthrax mentioned in the present section is apparently different from the kind described in section 18, which was almost certainly garnet. Since the anthrax of this passage is said to be like adamas, it is even more likely that it was spinel. Though adamas seems to have been a general term used for several minerals that were unusually hard, the descriptions of Pliny suggest that it generally referred to corundum, particularly the mixture known as emery. This frequently contains spinel in addition to corundum, and almost invariably magnetite, which is very similar to spinel in crystal form. The occurrence of large deposits of emery in Asia Minor, not far from the site of ancient Miletus, supports the relationship between this kind of anthrax and adamas. Most of the emery in these deposits contains only about 50% of corundum, and the remainder consists of the associated minerals, though it is remarkable that this particle 89. Lar mineral should have been called anthrax. The explanation may be that spinel not only occurs in the red transparent form, to which this name was applicable without question, but also in dark or black varieties that resemble the magnetite, which is often the most conspicuous component of emery. However, when anthrax is said to be similar to adatnus, the reference may be not to form or color, but rather to hardness, the special property for which adamus was noted. That would also identify this type of anthrax as spinel rather than garnet, since the hardness of spinel is close to that of emery, whereas the hardness of garnet is distinctly lower. 19. This power of resisting fire does not seem to be due to the absence of moisture, as is true of pumice and ashes, for these cannot be set on fire and burnt because the moisture has been removed. According to certain theories of Aristotle 90, which Theophrastus appears to follow closely here, stones like anthrax are incombustible because they contain no moisture and hence lack pores of the proper size to admit fire. For much the same reason, pumice and ashes are also incombustible. The difference is that they are produced from materials which originally contained moisture, whereas incombustible stones are free of moisture from the beginning. 19. Pumice. In the manuscripts, this word appears as, except in one place in this section where it is. The correct form is, which is used by all authors except Theophrastus. The descriptions in sections 20, 21, and 22 indicate that the word sometimes denoted certain cellular or friable rock material that would not now be called pumice. But the localities that are mentioned show that ordinarily the term had the same meaning that the word pumice has today, and for that reason it has been so translated. Pliny 91 shows that the corresponding Latin word pumex also had a slightly broader meaning than the modern term, though it is equally clear from his account that the word normally had the same significance. 19. Some think that pumice is formed entirely as a result of burning. The ancients apparently made little or no distinction between true combustion and other high-temperature phenomena, as was mentioned in the notes on section 14. Evidently, fire was a term that included all phenomena involving light and a high temperature. Therefore, when Theophrastus speaks of the origin of pumice from burning, combustion is not to be understood, but rather the formation of this material in the usual way by the expulsion of gases from molten lava. Superficially, of course, this process sometimes closely resembles actual combustion, especially when, as often happens, the gases evolved in the volcanic action take fire. 19. With the exception of the kind that is produced from the foam of the sea, the pumice that was thought to be produced from foam is clearly the same as the floating pumice still found around the shores of islands in the Aegean Sea. Such pumice emanates from the active volcanic island of Thera Santorin, where considerable quantities are to be seen floating on the surface of the water. Theophrastus evidently believed that it was formed in some way from the foam of seawater. This notion may have been obtained from Aristotle, for in a treatise on plants usually ascribed to the latter, a theory is advanced to explain how floating stones could be formed from seawater. According to the author of this treatise, such stones were produced by the violent collision of one wave with another. First of all, foam is produced which congeals with the consistency of oily milk. When the water is dashed against sand on a beach, the sand collects the fat part of the foam, which dries with an excess of salt from the water, so that the particles of the sand cohere and ultimately become stones. 20. The porous stone which changes to pumice when it is fired. Both the name and the nature of this stone are uncertain. Wimmer retains the manuscript reading, which is accepted by all the editors except Hill, who substituted the word printed incorrectly with a rough breathing, and translated it as Arabic stone, which according to Dioscorides 94 and Pliny is a substance resembling ivory. There seems to be little justification for this conjecture. Since Theophrastus is discussing pumice and similar cellular stones, it seems probable that there is merely a slight error in spelling, and that the reading should be a word meaning porous. The stone itself may have been a volcanic tufa of some kind. The negative, which occurs before in the Aldine edition but is not in the manuscripts, is a difficult reading to interpret. If it is accepted, the passage refers to a stone which does not change to pumice when it is fired. However, the in the Aldine edition is in the form of an abbreviation of the same size as the relative pronoun, which, this occurs in manuscripts NC, though is written with a smooth breathing in manuscript A. Most of the editors prefer IE, which also changes, but Wimmer accepts the reading of Aldus. Since this is the more difficult reading and therefore harder to explain, it is easy to see why Wimmer felt obliged to adopt it. Actually, the evidence of the manuscript seems to carry more weight, and the acceptance of the reading RJ would make it easier to understand the meaning of the passage. There are many misprints in the Aldine edition. It is quite possible that the abbreviation representing OV is not correct, and there is no evidence that Aldus had another manuscript from which he might have obtained this reading. It seems best to accept since it appears in two of the manuscripts. If RJ or, which appears in A, is correct, then some other verb must have dropped out before it, but it is possible that the smooth breathing is a mistake, and certainly it provides no evidence of a commentary. Negative. The genitive is plamdeumovetus is also a problem sense. Poyomoev, which when it is fired might be expected. 20. For pumice is found especially in places that the phrase evuros is incomplete. The meaning seems to be in places like this, i.e. in craters of volcanoes. Schneider suggested nu tauomacron kapal phio taomacron muno microniota, which would mean in places that are on fire. Turnibus gives in ardenibus as a Latin translation. A word ending in rots might easily have dropped out after evuros. Thus tupicaf toi would mean places that have been subjected to burning. Other possibilities are Ev Tauroses in these places, or Ev Tuatolutals in such places. 21. Nisiros. This is an island of volcanic origin in the southern Aegean near the coast of Asia Minor. Eruptive rocks of various sorts are found there. From the description, it seems likely that the material that was found was a loosely compacted volcanic tufa or ash rather than a pumice, though the reference may be to an especially soft and friable kind of pumice. But some. 21. The kind found in Melos is all. Since an adjective seems to be missing after a sigma of, Schneider suggested that nuyot alpha delta alpha might be changed to epsilon theta halpha upsilon sigma to omicron, easily broken, followed by ev in I0WDE, but Stephanides proposed sigma epsilon deltanu nu nuyota, almost as in Nisiroses, followed by alpha 8AV. 22. They differ from one another in color, density, and weight. It should be noted that the various kinds of pumiceous or scoriaceous rocks are distinguished only by their physical characteristics, for no hint is given that Theophrastus may have considered possible differences in composition. 22. The kind that comes from the lava stream in Sicily is black. This black variety probably would not be termed pumice in our modern system of classification, but rather volcanic scoria. The article is needed and has been added to the text. 22. The malodes. The word palamdodens, which is the reading of the manuscripts, does not occur elsewhere. It is possible that it is a mistake for unlambdadens, meaning quince yellow, and could be called a pale yellow kind, though such an adjective should have the article n before it. It was evidently taken so by Stephanides, who translates it into modern Greek as toipivos. Pumice made yellow by disseminated sulfur is a material of common occurrence in Sicily and the neighboring volcanic islands. However, there have been other interpretations. Turnebus changed the word to owens, Ferlenus preferred VWDN as a millstone, and Schneider suggested Mia the Melian stone. Stephanides finally decided in favor of Enmovlum Dodens, but it is hard to say which is correct. It seems best to add 5 to the text. 22. The one that comes from the lava stream can cut better than the white kind. This is another indication that the black pumice was volcanic scoria, and the white kind are ordinary pumice. It is interesting to note that Theophrastus, when he refers to the practical value of pumice, alludes only to its use as an abrasive. Later ancient writers emphasized medicinal uses. This explains why white pumice is here considered a less desirable kind, whereas such writers as Dioscoride and Pliny state specifically that the best. Pumice is recognized by its white color, its lightness, and the ease with which it can be powdered. 22. But the kind that comes from the sea itself cuts best of all. This is another reference to the floating pumice mentioned in section 19 and discussed in the notes on that section. The article N has been added to the text. 22. But we must consider elsewhere the causes of the differences between stones that either burn or do not burn. This vague promise or cross-reference is similar to the one at the end of section 38, and very similar to the one at the end of the last section of the treatise on fire. No further treatment of combustible and incombustible stones is to be found in any other extant work by Theophrastus. He does, however, in his History of Plants, 101 gives some additional information about pumice. 23. Sardion, Iaspis, and Sepharos. For the identification of these stones, see sections 30, 27, and 37 respectively. 23. Smaragdos. Though the word emerald is derived from the Greek sigma mopaidos, which has often been translated in this way, the accounts of early writers show clearly that in ancient times various stones of pronounced green color were listed under this name. The statements of Theophrastus make it doubtful whether true emerald was even known to him, and there appears to be no certain evidence on other grounds of its use among the Greeks. On the other hand, the more detailed descriptions of Pliny indicate that emerald was known as smaragdus in his day, and archaeological discoveries afford ample proof that the Romans made use of this precious stone. But Pliny, who states that there were 12 different kinds of smaragdus and describes some of these varieties, makes it clear that a number of minerals other than the particular variety of beryl called emerald were included under the ancient name, though it is impossible to determine with certainty what all of these were. Probably any transparent or translucent green mineral that resembled emerald, even one as common as green quartz, would have been classified under smaragdus, and Pliny's descriptions and the localities that he mentions indicate that certain copper minerals, such as malachite, were classified in this way. It is also probable that imitation greenstones composed of glass or stained rock crystal were given the same generic name. Pliny alludes to the existence of books which contain directions for staining quartz in imitation of smaragdus and other precious stones, a fraud, he remarks, that was more lucrative than any other. Seneca also mentions the staining of stone to resemble smaragdus. The Stockholm Papyrus, which contains numerous recipes for the imitation of precious stones by the staining of rock crystal, shows that there was a substantial basis for these remarks. According to this papyrus, green precious stones were counterfeited by applying copper salts and organic coloring materials to quartz after its surface had been roughened. Rock crystal colored in this way could not have passed for a clear, transparent green stone like emerald, though counterfeit stones of this kind may well have been a tolerable imitation of translucent green quartz. Whether such imitations passed for natural stones is uncertain, but the wording of the recipes indicates at least that they were known by the name smaragdos without qualification, since the recipes given in the papyrus for imitating this particular stone are about equal in number to all the recipes for imitating other kinds of stones. It is clear that these counterfeit green stones were frequently used by the ancients. 23. It makes the color of water just lie its own. This supposed property of smaragdos is not mentioned by any other ancient writer, though Pliny in a somewhat analogous passage remarks that from a distance such stones appear larger than they really are, because their green color is reflected by the surrounding atmosphere. Some commentators have supposed that this statement of Pliny was based on a misinterpretation of the present passage in Theophrastus, and King even supposed that Pliny's account represents the original sense of the Greek passage, and that water, which now appears in the text, is a corrupt reading for air. Actually, the statement of Pliny is so different that it is unlikely that he paraphrased or even used Theophrastus at this point. When Theophrastus says that water is colored by smaragdos, his statement apparently has a rational basis. For under proper conditions, bright green stones do impart a greenish cast to the water in which they are submerged. The phenomenon is best seen when the illumination is oblique and the stone is placed in a small opaque white vessel. It is rather curious that the same property is not ascribed to precious stones of other colors, for these can also impart their color to water through reflection, especially when they are transparent and highly colored. However, few of the stones used for seals by the ancients were as brightly colored as smaragdos, and this may be the reason why the effect was noted only in the case of this one stone. It is possible, too, that Theophrastus may have based his statement on a single observation of smaragdos, and that he did not attempt to experiment with other stones to see if they behaved in a similar way. 24. It is also good for the eyes, and for this reason people carry seals made of it, so as to see better. The verb pi without a preposition following it does not mean to look at but to see, and some adverb like ev, well, is really needed here for clarity. The meaning must be to see better, or to improve their sight. Pliny dwells at length on the pleasing green color of smaragdus and its supposed beneficial effect on the eyes. Though Theophrastus classifies smaragdos as one of the stones on which seals are engraved, Blamner 111 inferred from the wording of this particular passage that the allusion is to uncut ringstones. This conclusion is apparently supported by Pliny's statement that it was forbidden to engrave the surface of smaragdus. Since Roman emeralds were rarely engraved, Pliny's statement seems to be confirmed, and it is probable that he is speaking of true emeralds at this point. However, since no emeralds of purely Greek provenance have been found, it seems reasonably certain that Theophrastus is not alluding to emerald here. The early Greek gems described by Furtwängler, which are green in color, are all made of quartz, and it is very probable that here, and in the previous sections where Theophrastus says that smaragdos was used for seals, green quartz in the form of plasma or praise is to be understood. 24. But it is rare and of small size, unless we are to believe the records about the Egyptian kings. Elsewhere in the treatise, Theophrastus alludes to the scarcity or small size of the smaragdos seas, 8,262,734, and some writers 115 have concluded that emerald is meant whenever he alludes to the stone in this way. There is, however, no evidence that Theophrastus ever used the name smaragdos for an emerald. Moreover, the stones listed with it in section 8, which he describes as small and rare, are not especially rare, and are not always small. In these respects, they differ little from plasma or praise. Therefore, when Theophrastus refers to smaragdos in this way, he may well be speaking of the green quartz commonly used as a seal stone by the Greeks. Although there was probably some real basis for the reports about smaragdoi of great size, Theophrastus shows clearly by his wording that he hesitated to accept these accounts without question. This was not because he thought that greenstone objects of large dimensions did not exist, but because he doubted that the kind used for seals ever occurred in large masses. Certainly, if the accounts concerning them were not mere inventions or gross exaggerations, these large Egyptian smaragdoi could not have been actual precious stones. It is possible, however, that they may have been composed of malachite, which even now is sometimes regarded as a semi-precious ornamental stone. This native copper carbonate has been found in the form of solid blocks weighing several thousand pounds. In fact, it is the only bright green mineral substance that occurs in such large pieces. In modern times, the copper mines in the Ural Mountains have been the source of some very large blocks of malachite. For example, the largest piece of flawless malachite said to have been found in the mines at Gumashevsk weighed about 3,000 pounds, and in 1855 a mass was found at Nizhny Tagilsk that weighed around 50,000 pounds, though this was of inferior quality. It is quite possible that single pieces of malachite of huge size were also found in the early stages of working some of the great copper deposits of antiquity. That the mineral was available to the Egyptians is certain, since malachite was evidently the chief ore in the copper mines of the Sinai Peninsula, which were for centuries important sources of copper and copper minerals for Egypt. The block of Smaragdos 64 V2 fort that is said to have been sent to Egypt by a Babylonian king is as large as some of the modern objects made of polished malachite, such as the tabletops, bathtubs, and panels for walls or columns, which can be seen in certain European museums and other buildings. But it is improbable that malachite could have been the material of the 4 stones about 60 feet long mentioned as being placed in an obelisk. However, in the next section, where Theophrastus mentions a large pillar of green stone, he definitely suggests that this may have been composed of false smaragdos, a term that almost certainly denoted malachite. But this statement cannot provide a definite identification, since it is apparent that Theophrastus had no first-hand knowledge of the substance from which these large objects were made. The tradition that the malachite columns now in the Church of Hagia Sophia at Constantinople originally came from the Temple of Diana at Ephesus suggests that large pillars of malachite actually existed in antiquity. It seems probable, therefore, that these Egyptian smaragdoi were composed, at least in part, of malachite, unless they were made of some common massive green rock such as serpentine, which is known to occur frequently in Egypt. But there is a serious objection to identifying them as serpentine or some other green rock, for the term smaragdos was apparently applied only to mineral substances of a bright green color. That these huge smaragdoi were made of green glass, as some have suggested, is not very probable because, as Partington has pointed out, it is very doubtful from a technical standpoint that such enormous pieces of glass could have been successfully fashioned by ancient glassworkers. The existence of large smaragdoi in Egypt is mentioned by other ancient writers. Pliny, for instance, after quoting the statements of Theophrastus almost word for word, mentions a recent example in the Labyrinth of Egypt. There Apion saw a colossal statue of Serapis, 9 cubits in height, which was composed of smaragdus. 25. Tanoi. In the manuscripts and the Aldine edition, the first part of this word is missing, and only the last 4 letters AVWV have survived. Turnebus, who was followed by Hill, thought that the best emendation was RAVWV. The emendation of Furlanus, which Wimmer preferred, was Bablavov. It is true that stones from Bactria are mentioned by Theophrastus in section 35, and Pliny lists the Bactrian as a particular variety of smaragdus. But both Theophrastus and Pliny say that Bactrian stones are small, whereas the stone in question here was evidently a mineral substance found in pieces of considerable size. Moreover, as the notes on section 35 explain, it is highly probable that Pliny classed the Bactrian stones as one kind of smaragdus only because he misunderstood the meaning of Theophrastus in section 35. The evidence for the reading RAVWV is that Pliny clearly lists tanos as a kind of smaragdus. He also adds that it came from Persia and was of an unsightly green color. His descriptive details seem to indicate some source other than the present passage of Theophrastus, unless the information given by Pliny was originally contained in this passage and dropped out later. This possibility is not at all unlikely, since almost all the other passages in this same section of Pliny's work are direct quotations from this part of the treatise. It is impossible to determine what was originally written in the lacuna before the letters AVWV, and it is significant that Delay made no change in the reading of the manuscripts, since he was not satisfied with either of the 2 proposed emendations. Stephanides has recently decided in favor of RAVWV, and this is certainly better than, though both the locality and the brief description of Tanos given by Pliny apply to green turquoise. The large size of the stone mentioned by Theophrastus is definitely against this identification. Possibly Tanos was the proper name for green turquoise, and the large slab at Tyre was actually composed of some other stone that only resembled this mineral. Theophrastus appears to have this possibility in mind when he suggests that the material of the slab may have been a false smaragdos rather than Tanos. The former term was clearly used to denote malachite. Green turquoise and malachite, because of their similar appearance, were apparently often confused in ancient times. And this confusion is not entirely absent from the works of modern writers who have attempted to identify the green stones used by ancient peoples. 25. Tyre. Very likely Theophrastus obtained part of his information about this huge green stone from Herodotus, who visited Tyre and saw this remarkable column or slab which he describes briefly. Herodotus says that the column shone at night, and some commentators have suggested that it may have been composed of colored glass with a light inside it. Though this seems an attractive explanation because of the reputed skill of the glassworkers of Phoenicia, the descriptions apparently refer to a natural stone rather than to an artificial material. Furthermore, as was pointed out in the notes on section 24, it is highly improbable that ancient artisans could have fashioned any very large object out of glass. If it was composed of glass at all, this column must have been made of numerous small pieces fastened together in some way. On the whole, it seems much more probable that it was made of some natural material. Though this may have been malachite, serpentine is an attractive possibility, since not only is this green stone found in large blocks, but some varieties are translucent enough to allow light to shine through the stone if it is in thin layers. 25. Heracles. In reality, this was probably the Tyrian Melkart, the Baal of the Old Testament, whom the Greeks identified with Heracles. 25. False smaragdos. Since this was found in copper mines in pieces of considerable size, it seems clear that it must have been malachite, the green basic copper carbonate. Probably the term was applied only to massive malachite, which was good enough to be used for ornamental purposes, since the earthy forms of this mineral were apparently included under the name chrysocolla. It is reasonably certain that the term false smaragdos was not applied to imitation greenstones composed of glass or stained rock crystal. 25. Chalcedon. All the manuscripts have the reading Capindovi Carthage, and this was accepted by Hill and the editors who preceded him. Schneider and Wimmer have changed the name to Zandolf Chalcedon. This must be right, as there are no islands near the site of ancient Carthage that are known to have any copper minerals on them. On the other hand, at least one of the prints, islands in the Sea of Marmara close to the shore of ancient Chalcedon, is known to have been the site of ancient copper deposits. The author of De Minerabilibus Auscultationibus names Osis de Monesos as an island of the Chalcedonians where the copper minerals Kianos and Chrysocolla were found, as well as the copper that was used for making certain ancient statues. Pliny lists Demonissus as one of the islands in the Sea of Marmara at the entrance to the Bosporus. This island has been plausibly identified with the modern Kalki, upon which there are copper minerals and traces of ancient mining operations. 26th, chrysocolla. This is mentioned again in sections 39, 40, and 51 as an ore or mineral found in mines. Though Theophrastus does not describe it anywhere, his repeated allusion to its occurrence in copper mines clearly indicates that it was a copper mineral. Later writers also mention that it occurred in gold mines, and some of them say that it was found in mines containing other metals. But this occurrence was evidently due to the presence of copper minerals in such mines, as is explicitly stated by Isidorus. In section 39, chrysocolla is said to occur in native Kyanos, which was azurite, the blue copper carbonate, showing clearly that chrysocolla in this case was malachite, the green copper carbonate. The kind of chrysocolla mentioned in this treatise evidently corresponds to the natural kind of chrysocolla mentioned by Pliny as an exudation or incrustation found in mines. Dioscorides states that the best kind of chrysocolla was of a leek green color. The descriptions given by ancient writers show that the name chrysocolla, or chrysocolla, referring to a natural product, was given to any bright green copper mineral that occurred as an earthy incrustation. From this it follows that the name must have denoted malachite, green copper carbonate, when it was in an earthy form, and also the amorphous green copper silicate, which is still called chrysocolla at the present time. However, the descriptions of Pliny indicate that chrysocolla as the name of a mineral was more often applied to malachite than to what is now called chrysocolla. From its peculiar name, which means gold glue, some scholars have erroneously concluded that the chrysocolla of the ancients was borax or some other soldering flux, though there is no basis for this conclusion other than the name and the stated use of the material. In the 16th, 17th, and 18th centuries, borax was frequently called chrysocolla, and this circumstance may have caused the wrong identification. The name was first given to borax by Agricola, who may have misunderstood its meaning. The method of using copper minerals for soldering gold in ancient times has evidently puzzled many modern writers on early technical arts, though the correct explanation was given at the end of the 18th century by Waite, who showed experimentally that malachite, for example, could be used as a solder for gold. All that is required is that some suitable reducing agent, such as charcoal or organic matter, should be present, and that the temperature should be high enough to reduce the mineral to copper, and to make this melt and alloy with the gold. It has recently been shown for the first time that certain types of ancient goldwork could only have been produced by a soldering process of this sort. Some Etruscan and Greek works of art contain delicate patterns formed by minute grains of gold, or very fine wire joined to a background of solid metal. It has been found by experiment that they could not have been joined together by the direct application of solder in the form of molten metal, or by any process of fusion welding. Furthermore, microscopic examination of examples of ancient goldwork has shown the use of this reduction method of soldering. It is interesting to note that this ancient method of soldering gold by the reduction of a copper compound in situ is the subject of a modern patent issued to a Mr. Littledale, who may be regarded as the rediscoverer of an old method of soldering which is used for gold work of great delicacy. The name chrysocolla was applied by writers later than Theophrastus to artificial copper preparations used for soldering gold. Pliny I describes a mixture of this sort. In addition, he mentions under chrysocolla a preparation that contained gold and silver in addition to copper salts. By further extension of the original meaning, the name was applied to alloys used for the soldering of gold. In the Leyden Papyrus X are two recipes, nos. 31 and 33, for the preparation of such gold solders. In number 31, the alloy of copper, silver, and gold is called. For remarks on the use of chrysocolla as a pigment, see the notes on section 51. 27. Iaspis. Though the word jasper is derived from the Greek tezigmawis and is often used to translate the Greek word and its Latin equivalent, iaspis. The one fact that is most certain about the ancient name is that it did not designate the kinds of opaque colored silica that are now called jasper. The descriptions of ancient writers usually show that the name denoted certain transparent or translucent stones, and there is no definite evidence that it was ever applied to an opaque mineral substance. Though Theophrastus does not allude clearly to iaspis as a transparent stone, there is no such uncertainty about the descriptions left us by other ancient writers. Pliny opens his account of the stone with the words, Vire et sepe tralucet iaspis is green and often translucent. Later he mentions a kind that resembles rock crystal. Pliny also alludes to imitations of iaspis made of glass. Moreover, the descriptions of Dioscorides show that the name was not applied to an opaque stone. Dionysius Periegetes describes it as being watery green and translucent, and cloudy. This is not an appropriate description of the stone that is now called jasper. Though there can be no doubt that it was not our modern jasper, there is less certainty about its positive identification. Since Theophrastus shows its relationship to smaragdos in this passage, one might infer that iaspis was a green stone, and this color is mentioned by all ancient writers who describe it. Indeed, some of them mention this color only, and in the Stockholm Papyrus, where a recipe is given for the preparation of an artificial iaspis, it is clear from the ingredients that the resulting product was a green stone. On the other hand, Pliny refers to iaspis of various other colors, such as blue and rose, as well as to a colorless variety. In fact, he classifies the best as having a shade of purple and assigns only third place to the green kind. He also mentions smoky and turbid kinds. Dioscordes 152 gives a similar but less extensive list of the varieties of this stone. The ancient descriptions seem to show that iaspis was a generic term that usually denoted those varieties of transparent or translucent quartz to which special names such as sardion or crystallose were not applied. Thus, the green kind was probably plasmo or chrysoprase, the smoke-colored kind was smoky crystalline quartz or smoky chalcedony, the rose-colored kind was rose quartz, and the blue kind was common blue chalcedony. All these varieties of quartz were used as materials for ancient engraved stones. It is significant that Pliny includes phragus or seal stone under the term iaspis. This suggests that iaspis was a name applied to some varieties of chalcedonic or clear quartz used for seals. It seems likely, however, that other minerals besides quartz which were similar in appearance were included under the ancient name. Thus it has been suggested that jade or nephrite was called iaspis in antiquity, certainly the kind of iaspis mentioned by Pliny, who describes it as a green stone with one or more white lines running through it, would seem to correspond to jade or nephrite. Pliny implies that this stone was used as an amulet and had its origin in the East, and both these clues tend to support this particular identification. In the same way, still other minerals such as fluorite, which in some of its forms resembles certain varieties of colored quartz, may have been classified under iaspis in ancient times. Theophrastus shows by his remarks in section 37 that certain kinds of true jasper used in antiquity were given particular names. See also the notes on that section. 2007, is said that a stone was once found in Cyprus, half of which was smaragdos and half iaspis, as if it had not been entirely changed from the watery state. This passage is quoted by Pliny, who has clearly obtained his information from Theophrastus. His wording is as follows: et in Cipro inventum ex dimidia parte smaragdum, ex dimidia iaspidem, nondum umori in totum transfigurado. Here the Latin umor reproduces the Greek, which can be translated as the watery state or its watery state. The sense of the passage seems to be that a piece of stone or a crystal was once found in Cyprus, half of which had the green color of smaragdos, while the other half had a limpid or watery appearance and was probably colorless or only slightly colored. This could have been green quartz in a matrix of clear, colorless quartz or colorless chalcedony, though it seems rather more likely that the allusion is to a crystal. Crystals of this sort are not uncommon. Tourmaline frequently occurs in the form of transparent crystals that sometimes are green at one end and have a different color, or are colorless at the other end. It is easy to see how mineral occurrences of this kind would lead to the idea that one sort of precious stone could originate from another. Many later writers on mineralogy advance this idea, though Theophrastus was the first to express it. 28. Lingurian. This substance is also mentioned by other ancient authors such as Strabo, 6 Dioscordes, 7 and Pliny. Though many commentators have tried to identify it, unfortunately they have disagreed in their conclusions. Some have thought that it was a fossilized animal substance, others that it was a particular kind of precious or semi-precious stone, others that it was amber, and still others that it was a kind of fossil resin resembling amber. Some early modern writers on mineralogy identified this substance as belemnite, fossil cuttlefish bone. De Boot 159 gives Lincurius as a synonym for belemnite, and later writers such as Woodward Zero definitely identify the Lingurian or Lincurium of the ancients in this way. However, as Hill, Watson 162 and Beckman 1 have clearly pointed out, it could not possibly have been belemnite, since this fossil substance does not have the hardness, the transparency, or the electrostatic attractive properties ascribed to lingonon or lincurium. The lingonon of Theophrastus has been most often identified with a particular kind of precious or semi-precious stone. Delaye, who referred to an earlier suggestion of Epiphanius, says that the description of lincurium is certainly not inappropriate to the hyacinth of modern writers. Hill rightly rejects its earlier identification with belemnite, but, ignoring the possibility that it was amber, he decides with Delaye that it was hyacinth. Apparently he uses this word to describe certain varieties of garnet. Watson identifies the lingonon of Theophrastus with tourmaline. But evidently his opinion is partly based on the attractive properties of heated tourmaline which had recently been discovered. This identification is repeated by various later writers. For example, Dana 167 states that lincurium is supposed to be the ancient name for common tourmaline. However, the absence of tourmaline among surviving examples of ancient gems is clearly against this view. Its identification as red garnet or red tourmaline may have been based to some extent on the emendation flame-colored, which was substituted by Furlanus for the manuscript reading cold, and was adopted by several editors, including Hill. Wimmer has the manuscript reading in the neuter form, though the emendation seems to agree better with the description of its color colorum igneum given by Pliny, who apparently derived his information from this account of Theophrastus. The manuscript reading is more suitable, since it is evident from section 31 that the color of lingonon was yellow. The suggestion has been made that it was the stone known today as the hyacinth or jacinth 169, but this seems to be partly due to a confusion of mineralogical names. That lingonon could have been any of the gem varieties of zircon is highly improbable. No, ancient gems of zircon have been found, and since they occur principally in Ceylon, it is unlikely that the ancient Greeks could have been acquainted with them. Though the hardness and transparency ascribed to lingurion, as well as its use for seals, suggest that it was a kind of precious or semi-precious stone, certain of its qualities, as described by Theophrastus, show that it was not an inorganic material at all. In particular, the phrase kabapiat mios is like stone, used with reference to its hardness, definitely indicates that it was not a stone, and the electrostatic properties ascribed to it, though they could apply to a polished gem, point to a more easily electrified substance, such as amber, which is of vegetable origin. The explicit statements of Strabo, Dioscorides, and Pliny on the nature of this substance have not been sufficiently considered in many of the attempts to identify it. In his discussion of the territory of the Ligurians, Strabok's remarks, the Ligurian too is plentiful in their country, and some call this amber. Dioscorides says that the urine of the lynx, which is called lingurion, is believed to be transformed into a stone as soon as it is voided. And so it has a foolish story connected with it, for this is what some people call the amber that attracts feathers. In his discussion of the various names given to amber, Pliny says, Demostratus lincurium vocet, alios edi ser langurium demostratus calls it lincurium. Others call it langurium. After discussing the varieties, properties, and uses of amber, Pliny adds this statement. De lincurio proxim dici cogit octorum pertinacia, quippe, etiamsi non electromidi, tamen gemam esse contendunt, fieri autem ex urina quidem linces, sed e genera terrae, proteinasio animali urinum operiente, quoniam invidet homini ibic lepidicere.
Esse autem, qualem insoucinis, colorum igneum, scopic nec folia, tantum aut stramentat seraper, sidaris etiam ad sferi lamnas, quod diocliquidam Theophrastus quoque credit.
Ego falsum id totum arbitror nex visam in aevo nostro gemum ullum ea appellation. 175 The obstinacy of authors compels me to speak next of lincurium, for even though they state that it is not amber but a precious stone, yet they assure us that it is formed from the urine of the lynx, though it also contains a kind. 171 Lambdaeotagamagam omicron royotomicronu. Of earth, the animal immediately covers up his urine because of his envy of mankind, and there it turns into stone. Moreover, like amber, it has the color of fire, can be engraved, and attracts to itself not only leaves or straws, but even thin pieces of bronze and iron, as Theophrastus believes on the authority of a certain diodes. I consider that all this is untrue, and that a precious stone of this name has not been seen in our time. From these statements, it seems likely that the substance variously known as lingurion, lincurium, or langurium was none other than amber, and this identity has been upheld by some commentators. However, if the substance which Theophrastus calls lingurion was really identical with the one called electron, it remains to be explained why he discusses them as though they were different substances. Possibly he was unaware that the same substance was known under these two different names. Certainly his statements about the mode of origin of these two substances indicate a lack of first-hand information that might easily have led him to just such a confusion of names. On the other hand, when he says that lingurion had a high degree of transparency, he does suggest that there may have been a real difference between this substance and the one called electron, since the striated or clouded varieties of amber could not be so characterized. Possibly the name lingurion was a special one applied only to flawless varieties of amber valued for purposes of adornment, whereas electron was the general name for amber, or the name applied to the less valued varieties. Finally, there is the theory that lingurion was not genuine amber but some sort of fossil resin either allied to amber or resembling it, but this seems to be based on what Theophrastus says about its mode of origin. His statements certainly indicate that lingurion was found only in the ground, which is not true of genuine amber. However, it might also be inferred from what he says in section 29 that electron was also found in the ground, and was therefore not genuine amber. Hence his statements give no valid reason for regarding lingurion as different from amber. Actually, of course, the fanciful tale he tells about the formation commentary of lingurion shows that he personally knew nothing about this. That lingurion was not one of the soft fossil resins seems evident from the remark he makes about its hardness. On the whole, therefore, lingurion can be identified with reasonable certainty as either amber or some particular variety of amber. 28. Bits of wood. In quoting this passage about the attractive powers attributed to lingurion, Pliny 8 mentions leaves folia rather than wood. For this reason, Wimmer added the word leaves in brackets after wood, indicating that the text may have originally contained this word. Since Pliny is not always accurate in his quotations, this is far from certain. However, the context makes it clear that the word should be understood to mean bits of wood or shavings. Theophrastus does not say that it is necessary to rub lingurion in order to induce its attractive power, but other ancient authors also fail to mention this when they speak of the electrostatic attraction that amber displays. It is uncertain whether Theophrastus was even aware of the necessary part played by friction in producing this phenomenon, especially as his statements show that he was dependent upon others for his information. 28. Diodes. This is generally considered to be the earliest mention of Diocles of Charistos, a famous Greek physician and writer of the 4th century BC, who in all likelihood was for some time a contemporary of Theophrastus. At Athens, the significance of the allusion to Diocles for dating this treatise of Theophrastus is discussed in the notes on section 59:28. It is better when it comes from wild animals rather than tame ones, and from males rather than females, for there is a difference in their food, in the exercise they take, or fail to take, and in general in the nature of their bodies. So that one is drier, and the other more moist. Those who are experienced find the stone by digging it up, for when the animal makes water, it conceals this by heaping earth on top. Theophrastus appears to be the first to relate this curious story, but whether he was the actual author of it is uncertain. He may have depended, as for some of his other information about Lingurian, on the statements of other writers or, as is even more probable, he may be repeating a popular tale that was widely known and believed. This story undoubtedly arose from the name of the substance lynx urine, though its color and general appearance may also have been a factor in the origin of the story. It is not unlikely that someone tried to invent an etymology for the name after its original pronunciation and spelling had been corrupted and its real origin forgotten. Though Theophrastus fails to state explicitly in this treatise what animal was supposed to produce Linguria, the lynx is specifically named in all later accounts. Thus, for example, the animal is so named in the accounts of Dioscorides and of Pliny that have already been quoted. The animal is also named by Pliny in other passages 179 dealing with the subject, and in a fragment quoted by Photius 180 Theophrastus specifically names the lynx as the animal whose urine was utilized for seals. Theophrastus does not say anywhere how the liquid urine was transformed into the solid stony substance, but Pliny is explicit on this point. In one place 181 he states that the urine either congealed or dried, and in another place, where he seems to be depending more on the opinions of others, he says that it was the urine of the lynx and a kind of earth that hardened together to form the stone. Ovid remarks that the urine hardened on contact with air. It is clear from the variety of the explanations given by later authors, and even more from the other variations in the details of the story, that it must have been widely known and lost nothing from being retold.
The following passage from Pliny shows how many alterations were introduced into the story as it was passed along. Demonstratus lincurium vocat et fieri ex urina, lincum bestiarum, e maribus fulvum et ignium, e feminis languidius atque candido malios si dicere langurium et esse in Italia bestias languros. Xenothemis langas vocat isdem et circa padum is vitam adsignat. Sudines arborum, quae gignat in Liguria, vocari linca, in iadem sententia et metrodorus fuit.
Demostratus calls it lincurium, and says that it originates from the urine of the animal known as the lynx, that of the male being reddish and fiery, that of the female rather pale and even white. Others call it langurium, there being in Italy animals known as languri. Xenothemis calls them longai, and assigns the region of the Po River as their habitat. Sudine says that the tree which produces it in Liguria is called the lynx. Metrodorus also was of the same opinion. Perhaps the most curious elaboration of the story was the belief that the lynx hid its urine because it did not wish men to possess the valuable stone formed from it. Pliny mentions this strange belief in two passages, 186, one of which has already been quoted. It is also mentioned in section 76 of the pseudo-Aristotelian work De Mirabilibus Auscultationibus. The passage reads as follows: Kappa alpha tau nu lambda kappa delta phi alpha tau omicron ronu, kappa alpha kappa tau epsilon iotanu delta iota tau pirho lambda alpha tau epsilon chizig myota munu epsilon alpha tau. They say that the lynx also covers up its urine because it is useful for seals and other purposes. Though Theophrastus says nothing about this curious belief in his account of the story in this treatise, it must have been current in his day, since he takes the trouble to refute it in the fragment quoted by Photius, which contains various examples of envy or jealousy felt by animals toward men. The pertinent passage reads as follows: Kappa alpha lambda iota gamaxi, kappa alpha tau alpha kappa hopa tau epsilon iota tau, omicron rumicron tau iota, pirho tau sigma firho alpha gamma delta alpha kappa alpha pirho lambda lambda alpha chirho epsilon alpha pi iota tau delta epsilon iota omicronu, lambda lambda tau iota munu omicron delta iota fifth and omicronu tau alpha tau alpha, pi omicron iota epsilon tau alpha, lambda lambda omicron nurho iota kappa tau delta alpha, pi omicron lambda psi epsilon, tau alpha tau etanu, alpha tau, pipsi alpha tanu alpha tau alpha nu tau delta lambda alpha. And the lynx conceals the urine because it is suitable for seals and other purposes. But it is obvious to everyone that animals do not do this from envy, but that men have brought this charge against them because of their own prejudice. This passage, though confirming the belief of Theophrastus that Lingurian was formed from the urine of the lynx, also indicates that the credulity of Theophrastus had its limits. Moreover, it seems to show that in the treatise on stones, Theophrastus may have purposely omitted the part of the story that accuses the lynx of hiding its urine owing to envy or jealousy. It is not unlikely that this fanciful explanation was generally considered an essential part of the story in his day. 28. This stone needs working even more than the other kind. This statement has been taken as evidence that Lingurian was a very hard stone that was difficult to cut or grind, though this difficulty is certainly not encountered in working amber. Whether this statement is true is by no means certain, especially when it is compared with the statements that precede it. But if it is assumed that it is true, or that it contains an element of truth, it may refer only to the time needed for polishing the material when it is cut. If this interpretation is accepted, the statement could refer to amber as well as to a hard stone, so that it cannot be taken as evidence that Lingurian was not amber or a variety of amber. 29. And since amber is also a stone, for the kind that is dug up is found in Liguria, the power of attraction would belong to this too. Theophrastus has previously mentioned Liguria as a source of amber in section 16. The boundaries of ancient Liguria were not well defined, though the territory was probably restricted largely to northwestern Italy at the time of Theophrastus. It extended far along the coast of southern Gaul at an earlier date. At no time, however, did it include regions where amber occurred, nor was amber found in any region near it at the time of its greatest extent. The truth appears to be that amber was brought from the coasts of the North and Baltic seas by trade routes through Gaul, and that the Ligurians acted only as traders in this product. Theophrastus, like all other classical Greek writers who touch on the subject, apparently knew nothing about the real nature or the real source of amber. Though Thales of Miletus is generally regarded as the first to mention that amber has the property of attracting light particles when it has been electrified by friction. His claim to this distinction actually rests on very uncertain grounds.
That Thales was the first to mention this property can be inferred only indirectly from the following statement of Diogenes Laertius in his discussion of Thales. Aristotelis dai kate pies phasen, adin katos psychis, metadidone psychas, tekmeromenon iktes lithutis magnetidos kai tu nekpov.
Aristotle and Hippias say that, judging by the behavior of the lodestone and amber, he also attributed souls to lifeless things. What Aristotle really says about this opinion of Thales is as follows: Omicronio to cap epsilon, delta cap alpha alpha shinu, p omicron manuetamo omicron epsilon omicron epsilon sigma iota, kappa iotenu etario to capanu tau iota tonu, c epsilon shinu, p omicron beta epsilonu. Epsilon p epsilon rho tonu lambda theta omicronu fiat c epsilon chinu, chi epsilonio tonu tau iota tonu sigma delta iota omicronu, kappa iota nu epsilonu. According to the reports made about him, Thales also seems to regard soul as a motive force, if indeed he said that the lodestone has a soul because it moves iron. In other words, Aristotle, whom Diogenes Laertius quotes, does not even mention amber in his corresponding statement about Thales. Of course, it may be inferred from these two statements that it was Hippias who said that Thales understood the attractive property of amber. But there is no way of confirming such an inference because the works of Hippias are not extant. It may even be that the allusion to amber in the statement of Diogenes Laertius is the result of a late interpolation, as has been suggested by Rossignol. The first clear indication that the ancients knew about the attractive property of amber is given by Plato, who very briefly alludes to it in his Timaeus, though he denies that it had a real power of attraction. The various statements of Theophrastus in sections 28 and 29 are certainly the earliest account of the properties of amber. 29. The stone that attracts iron is the most remarkable and conspicuous example. This also is rare and occurs in few places, though Theophrastus does not give a specific name to the lode stone in this passage. He has in a preceding passage, Chapter 4, apparently designated it as Heraclean stone. This seems to have been the common early Greek name for the lodestone, since Plato in one place specifically states that this was what most people called it, and in two other places he uses this as the name of the lodestone without special comment. However, the lodestone was frequently mentioned without the use of a special name, as in the present passage and in the passage from Aristotle that has just been quoted. It was sometimes described simply as the stone, without any explanation that it was the one that attracted iron. For example, Theophrastus so designated it in the following passage in his History of Plants, where he is referring to certain plants that affect lifeless objects, 8e, pi 196, and some also have the power of attraction, like the stone Sc, the lodestone and amber. Since the Greek world was so small and a very small area of the earth had been explored for minerals at that time, this statement of Theophrastus about the scarcity of the lodestone is undoubtedly correct for his day. Even at the present time, specimens of magnetite that are actively magnetic are not very common in spite of the abundance of the mineral itself. Although the statement in the present passage is a very early allusion to the phenomenon of magnetism, it is by no means the earliest that is known. As was indicated before, Thales of Miletus was probably the first to allude to this phenomenon, but the earliest direct statements about the lodestone and its special property are those of Plato. The passages in Plato's Ion constitute a particularly vivid description of the way the lodestone attracts iron. Though Plato in the Timaeus mentions amber and the lodestone together because of their attractive power, he does not suggest any particular connection between the properties of the two substances. Theophrastus is apparently the first to suggest explicitly that the lodestone should be classified with substances, such as amber, which exhibit the property of electrostatic attraction. Thus he may perhaps be considered the first to hint at a possible connection between what we now call electricity and magnetism. 30. Hyaloides. The name suggests some sort of glass-like stone, but it is mentioned by no other ancient author, and the very brief description given by Theophrastus is inadequate for certain identification. Various conjectures have been made by commentators. Hill, for example, supposed that it corresponded to the Asnon of Pliny, whereas Werner suggested that it might have been moonstone, and Lenz that it might have been a natural glass. Stephanides I believed that various reflecting and transparent stones might have been known by this name, particularly the lapis specularis of Pliny, which apparently included mica and selenite. Though it is quite possible that various materials of a glassy nature received the name, it seems unlikely that such soft minerals as these were included. For Theophrastus is speaking of a stone or igneous material upon which seals were engraved. The real objection to identifying it as one of the glassy minerals is that, with the important exception of the various forms of quartz, all of which appear to have been known by their own special names, practically no specimens of engraved gems executed in such minerals have come down to us. Therefore, it seems not unlikely that the name may have been given to the various glass pastes that were by no means uncommon as a material for seals at the time of Theophrastus. About 10% of the engraved gems of the Hellenistic and early Roman period that are listed by Furtwängler were executed in glass pastes of various colors. One objection to this identification is that Theophrastus would not be likely to list an artificial product like glass among stones of natural origin. However, his statements in section 48 of the treatise, where finished ceramic ware is described as stone, suggest that he would not have made any such distinction in classification. Judging from the reference Theophrastus makes to glass and vitreous earth in section 49, it is doubtful that he was aware of the artificial origin of glass. And even if he understood its mode of origin, it does not follow that he would have recognized that seals executed in paste were not made of a natural material, for since they were engraved, they were very different in appearance from large objects made out of glass by other methods. 30. Anthractym. This is mentioned again in section 33. See the notes on that section. 30. Omphax. The Greek word mu usually means an unripe grape or some other unripe fruit, but it was often used in a metaphorical sense. Perhaps Theophrastus is using it in this way here, as he appears to be the only author to give mu as the name of a stone. Galen 5 lists a stone with a similar name called mu omphatitis, but like Theophrastus, he gives no description. The name suggests that the stone resembled an unripe grape, i.e., it was green in color and in its natural state botryoidal. Furthermore, it is probable that it was either transparent or translucent, since the other stones discussed in this part of the treatise were not opaque. Practically the only mineral suitable for engraving that fulfills these conditions is prehnite, a hydrous calcium aluminum silicate usually colored apple green by impurities and occurring normally in botryoidal masses lining cavities and igneous rocks. Prehnite is capable of receiving a high polish and has been used in modern times for inlaid work and ornaments. 6. However, ancient engraved stones of prehnite have apparently not been found. And though this may seem to bring the identification into question, it should be noted that surviving examples of ancient non-opaque green stones are scarce. Even though early authors speak of such stones as though they were common in their day, possibly the stone was called omphax only because of its color. And for this reason it may have been some other stone such as green quartz. Stefanidis 07 suggested that it might have been the variety of quartz now known as chrysoprase, a translucent form of chalcedony-colored bright green by nickel. Here again, surviving examples of seals made of this material which would confirm the identification are lacking. Both these identifications should be regarded as conjectural, since the total lack of description makes it impossible to determine which particular stone was called omphax. 30. Rock crystal. This is the generally accepted identification of Putaus and, there can be little question that it is correct. In discussing crystallus, Pliny refers to the Greek name as a word meaning a kind of ice. He clearly describes the hexagonal form of crystal in quartz, and even mentions the occurrence of variations in the characteristic pyramidal terminations of the crystals, though Theophrastus lists it as one of the stones upon which seals were engraved. The small number of examples contained in modern collections of ancient engraved stones indicates that it was not commonly used for this purpose in his day. However, numerous specimens of engraved rock crystal of earlier date are known, about 5% of the carved Mycenaean stones described by Furtwängler, and less than 5% of the early Greek gems are made of this material, whereas less than 1% of the stones ascribed to the Hellenistic and early Roman period are made of it. In Roman times, rock crystal was commonly carved into relatively large objects such as dishes and drinking glasses, and these seem to have been highly valued. 30. Amethyst. There is little doubt that the stone named Amuevorov by Theophrastus was identical with our amethyst, a purple variety of quartz. He mentions rock crystal and amethyst in one phrase as though they belonged together, stating further that they were found when dividing other stones. Colorless quartz and amethyst are often found in this way, and sometimes they are found together, in veins or cavities of massive rocks. They are also found lining the interior of geodes, and are revealed when these stones are broken. In the next section, Theophrastus notes that Aovorov was wine-colored. These meager characterizations of amethyst are fortunately supplemented and confirmed by later writers.
Thus, Pliny speaks of amethystus. In this way causam nominis adferent quod usque et vinicolorum accidens priusquamium degustit, in violum desinat fulgor.
The reason for its name is said to be that it approaches the color of wine, but before it reaches this color it shades off into violet. In speaking of the varieties of amethyst, Pliny also says this: Quintum ad vicina cristalli descendit albicante purpurae defectu. A fifth kind approaches rock crystal very closely, the purple gradually fading off into white. The second quotation accurately describes the common kind of amethystine quartz, which is only slightly or partially colored, though it is likely that the same name would have been applied by the ancients to purple sapphire or purple fluorite because they are similar in color. There are no stones of this kind in collections of ancient engraved gems. This indicates that amethyst, if not the only purple stone known to the ancients, was at least the only one of this color that was engraved. About 3% of the engraved gems of the Hellenistic and early Roman period that are catalogued by Furtwängler are made of amethyst. 30. Sardian. The brief statements in this passage, when supplemented by what Pliny says about sarda, show that Sigma Raptioff was a generic name applied to those varieties of red chalcedony suitable for seals. These stones are simply quartz colored with small amounts of ferric oxide. Theophrastus plainly distinguishes two varieties, the one which is described as translucent but redder than the other. 12. The codes assigns for transactions where no currency is involved. VI 123 was apparently identical with what is now called carnelian, a bright red chalcedony of clear rich tint. whereas the darker kind probably corresponded to what is now called sard, usually a deep brownish red chalcedony that becomes blood red in color when light shines through it, though the color of the stone is sometimes so intense that it approaches black. It is interesting to note that both Theophrastus and modern writers on mineralogy distinguish only two varieties of red chalcedony suitable for gems, the difference being that a single name, suitably qualified, was used in his day, whereas two distinct terms are now employed. The ancients made abundant use of red chalcedony for seals, as is shown by the large number of engraved stones of this material that have survived to the present day. And apparently red chalcedony was more often engraved by the peoples of the Aegean region than any other kind of precious or semi-precious stone. About 20% of the Mycenaean engraved stones that are listed by Furtwängler, 35% of the early Greek stones, and 35% of the Hellenistic and early Roman stones are made of red chalcedony. This early preference for red chalcedony is noted by Pliny in these words, Nec fuit alia gemma apud antiquos usu frequentur. Among the ancients there was no precious stone in more common use. Carnelian was apparently the variety generally preferred in the earliest periods, and sard came into widespread use only in the Hellenistic period. About 40% of the stones made of red chalcedony that are listed by Furtwängler as Hellenistic are classified as sard, whereas less than 5% of such stones that belong to the early Greek period are classified in this way. Possibly the exhaustion of the old sources of red chalcedony or the discovery of new sources would account for this variation in distribution, though it may have been simply the result of a change in fashion. 30. And there are others, as has been mentioned before, which differ from one another, though they have the same name. No previous statement of this kind occurs in the treatise as it is now known. However, at the beginning of section 23, where the differences in stones used for seals are mentioned in a general way, it is possible that something is missing that was contained in the original form of the treatise. For this reason, Schneider proposed an emendation in section 23, which is listed in the critical notes on the text. 31. And it is the same with the varieties of the Ligurian, for the female is more transparent and yellow than the other. Also, one KJND of Chianos is called male and the other female, and the male is the darker of the two. The curious ancient distinction of sex in precious stones, which is mentioned in other early works, was apparently not connected with theories about the origin of stones, or even with the belief that certain stones had the power to generate others. A possible exception may be the supposed connection between the properties of the Ligurion and the sex of the animals alleged to produce the two varieties. 28. Theophrastus is perhaps referring to this again in the present section. However, this connection should probably be regarded as accidental, for it was explained in the notes on section 28 that in all likelihood Ligurian was not an inorganic substance but either amber in general or a special variety of amber. It seems significant that similar modes of origin are not given for any true precious stone. It is likely that the concept of sex in stones was current long before the invention of the story about the Ligurian and was actually one of the sources from which it originated. In general, this concept was used to distinguish varieties of the same precious stone on the basis of their color, their relative brilliancy, or some other distinctive property. Thus, as he shows by his statements in this and the preceding section, Theophrastus relates sex in stones to transparency or color, assigning the male sex to the kind that are darker in color and the female sex to the ones that are paler. Pliny relates sex in stones both to color and to the relative brilliance of varieties of the same stone. For example, he describes the kinds of carbunculus in this way: praeterea in omni genere masculia pellentur acrioris et feminae languidius refulgentis. 92, 124. Moreover, in each kind the more brilliant are called male, and those that shine with a fainter light are called female. He also makes a similar statement about Sandastros. In discussing sarda, whose varieties Theophrastus distinguishes only by their color and transparency, Pliny has this to say: Et in his autem maris excitatius fulgent feminae pigriores et crassias nitont. Among these stones too, the males glow more brightly, but the females are rather dull and shine with a dimmer light. It will be seen, therefore, that according to this ancient concept of sex, all stones of a certain type whose characteristic properties were more pronounced were called male, and those whose properties were less pronounced were called female. Though Theophrastus is apparently the earliest known writer to use this concept, his phraseology indicates that he did not invent it, but merely incorporated it into his treatise as a method of distinction commonly understood in his day. Theophrastus also varies the grammatical gender of the word, used for stone, which sometimes appears as o-litos and sometimes as litos. Although the occurrence of this word in the treatise has been carefully studied, no clear distinction in meaning between the two genders has been found. And the problem is not solved by the suggestion in Liddell and Scott's lexicon that the feminine usually applies to some special stone. What is probably near the truth is that the grammatical gender of the word was unsettled in the early formative period of the language, so that the word was used in either gender interchangeably. Efforts were later made to straighten out the confusion by assigning special meanings to each gender. Galen shows that the argument not only concerned the word eidos, but extended also to o-terpos and terpa. The term used for hard stones and rocks, he points out the futility of the attempted distinctions, and shows his impatience in the following words: Mupial phalam diotanu delta tanu pitor halphanu, lambda gamma omicron upsilon sigma iotanu, thete talam dupsilon kappa, omicron tanu pitor humicronu warho epsilonu iota kappa.
Yigagon exepitides. Evotha, metavalante nomata, legina catero sepadatethiata, pergon Christos serisus ingeni, dignas, hergem miden vlaptomen intensafinian arminias, hypoteros kentis.
Elt, and again they speak of stone in the feminine, not of stone in the masculine. At any rate, my custom is purposely to interchange the names, and to adopt both methods of describing everything of that sort, which some people argue about so unprofitably, for I show that in fact the clearness of the interpretation is not harmed at all, whichever way one describes them. 31. Kaianos. Theophrastus uses the word quavos to designate two quite different types of material. In the present passage and in section 37, it evidently means a blue precious stone. But in sections 39, 40, 51, and especially 55, it is the name of certain natural or artificial substances that were used as blue pigments. There is also the stone called andipos, but the statements of Theophrastus in section 37 and the descriptions of Pliny show that kaianos and sepharos were simply varieties of the same mineral, since the latter stone, as is explained in the notes on section 37, was almost certainly a variety of lapis lazuli. It is equally certain that the stone called kaianos was also a variety of lapis lazuli. The difference apparently was that sepharos was the name given to the mineral when it contained numerous scattered specks of iron. Pyrites, whereas kaianos was the name used for the stone of solid blue color, or at least the stone in which iron pyrites were not present in noticeable proportion. Lapis lazuli ordinarily contains various other impurities such as mica, calcite, amphibolite, and diopside, in addition to the intense blue mineral lazurite, a complex sodium-aluminum sulfosilicate, which determines the color of the mixture as a whole. In proportion to its content of lazurite, the color of lapis lazuli varies from a very deep blue to a light or even greenish blue. Probably Theophrastus is referring to these differences in depth of color when he distinguishes the varieties of kaianos according to sex. Though he lists kaianos among the stones used for seals, lapis lazuli, which is frequently intersected by hard crystals formed of minerals other than lazurite, is not very suitable as a material for engraving. And its scarcity in modern collections of ancient engraved gems shows that it was not often used for. 221 Texaxi this purpose. However, it was extensively employed in ancient times for various ornamental purposes, as is shown by the numerous specimens that have survived. In Egypt, for example, it appears to have been used ever since pre-dynastic times for beads, amulets, and other small objects, 2 inches too, and very early specimens from the Aegean region are known. But since there is no ancient or modern source of lapis lazuli in the vicinity of the Mediterranean, the stone must have been imported from a considerable distance. Persia is often given as the source, but geological investigations appear to show that it was, at the most, only a minor locality for lapis lazuli, since no important deposits or indications of ancient workings are known. The only definitely established source of lapis lazuli for the ancient world is the very remote mine at Seri Sang in the upper Kokcha Valley between Parwara and lower Robat Badakhshan, which some think was the only commercial source in ancient times. 31. Onychon. Though the description of this stone seems to fit what is now called onyx, a banded chalcedony in which the layers, alternately white and dark in color, lie in planes one above the other. The word onychon has been used in the translation because there are definite indications on other grounds that had a broader meaning than the English word onyx. There seems to be no reason to doubt that the stone was banded chalcedony, since this is practically the only kind of striped stone to be seen among surviving examples of ancient engraved stones. But the term onychon might have included striped chalcedony, in which the layers are not flat but angular, wavy, or concentric varieties to which the name agate is now assigned. The descriptions of onyx given by Pliny, though in some respects obscure and contradictory, definitely show that at least in his day the term not only included our onyx but striped agate also. That agate, for example, was classified as a kind of onyx is very clear from his account. Pliny's use of the word onyx for alabaster or onyx marble is another indication of the broad sense of the ancient term. Blumner suggested that the word onychon might have had a more restricted meaning at the time of Theophrastus, or that Theophrastus was only acquainted with a particular form of banded chalcedony. This does not seem likely, however, since all the common varieties of striped chalcedony were in use as gems at the time of Theophrastus, and Theophrastus lists in his treatise nearly all the stones then used for the purpose. Since he does not distinguish onyx, sardonyx, and agate by special names, the best explanation is that onychon was a general term that applied to these banded chalcedonies as a class. So far as we know, Theophrastus is the first writer to mention and characterize such stones. Banded chalcedonies of all sorts were very popular in antiquity as engraved stones, and some of the most beautiful ancient examples were executed in onyx or sardonyx. These were naturally the most suitable stones for large cameos, and a few remarkable specimens have come down to us. 31. Achates. Although the English word agate was derived from axarnes and the Greek word has often been translated in this way, it seems reasonably certain that the ancient name did not have the same significance. Though he mentions its beautiful appearance, Theophrastus unfortunately gives no descriptive detail by which the stone can be identified. Nor does Pliny in his account of achates give any clear description of the stones included under this term. For the most part, he merely lists varieties, though the names of these, being based upon color or some other distinctive property, afford some definite information. His brief characterization of dendrochates, for example, indicates that achates included at least one kind of true agate, the distinctive dendritic or moss agate. And this identification receives confirmation from the beautiful description of a stone with a similar name contained in the Orphic poem Lithica of about the 4th century of our era. It is certain, however, that all the varieties of our agate were not included under the term achates, for Pliny clearly describes banded agate and iagate as varieties of onyx. Blumner, who thinks the ancient term was restricted to certain kinds of agate, is probably not far from the truth, though it is by no means certain that only variegated agate was included under the term achates, for it seems evident from the descriptions of Pliny that some stones were then included that would not be classified as agates at the present time. Since the ancient systems of mineral classification were based upon appearance rather than composition, it is likely that any kind of attractive stone in which irregularly placed spots, streaks, veins, or other markings appeared against a background of contrasting color would have received the same general name, though probably it was usually applied to irregularly marked chalcedony, and possibly to jasper. For these forms of quartz are the most abundant and generally the most attractive of the variegated stones. 31. The river Achates. According to the studies of Holm, this river was probably either the modern Carabi or the Canatello in southwestern Sicily. 32. Lampsacks. This was a celebrated Greek settlement in Mysia, on the Hellespont. 32. Astera. Tree name of the town to which the stone was sent is uncertain. The manuscripts have or, which cannot be correct. Turnebus changed this to, and Delayet suggested that, would be better, but it is unlikely that Tyre the city in Phoenicia is meant, as that was on the coast in the participle, which means carried up, suggests that the stone was taken to some inland town. Actually, the Greek for Tyre is. Thus appears in section 25. For Lenus proposed the accusative of opupa, a hammer. Schneider suggested arupa, which is close to the manuscript reading. This form is the accusative neuter plural. Astera was a town in the Troad, inland from Lampsakos, and there was another place of the same name near Antandros in Mysia. Professor Gilbert Higgett suggests that Rarepov should be read. This would mean that the stone was carved into a portrait of Statira, who was the wife of Alexander the Great, 233 according to this interpretation. Avivexoions would mean when the stone had been brought up from the mine.
32. The king. That the king was Alexander the Great is indicated by a passage in Pliny which reads as follows. Gemai nascuntur repente novae sine nominibus. Sicuro limin metallis oraris lampsaci unam inventam. Quae propter pulchritudinem Alexandro regimis assit. Auctor est Theophrastus. New gems which have no names are also produced unexpectedly. For example, Theophrastus reports that a stone was once found in the gold mines at Lampsacus, which was sent to King Alexander on account of its beauty. However, it is not certain that Theophrastus does mean Alexander. Pliny may have added the name on his own authority. 33. Anthrakion. Since Nuthatarho Kapaio Tomikronu is evidently a diminutive of Nuthatarhal Faxi, Hill and later commentators 236 thought that it might be the name of an inferior kind of garnet. But the hints that Theophrastus gives about the nature of the stone do not support this identification. In the notes on section 18 it was pointed out that the word anthrax meant originally a glowing live coal, and was applied later to stones of a similar red color. But since this word was also used to denote charcoal, it is equally reasonable to believe that the derived form anthrakion was one applied to very dark or black stones. The statements made by Theophrastus agree with this interpretation, for the anthrakion found at Orchomenos is described as darker than another kind called the Chian, and this suggests that it was very dark in color, especially as the only Chian stone mentioned by ancient authors was apparently a black or dark rock variegated with spots or streaks of lighter colored mineral matter. It will be recalled that Theophrastus alludes to this Chian stone in sections 6 and 7. What probably misled Hill and other commentators is that Pliny, in quoting, or rather paraphrasing, this passage of Theophrastus, placed it at the end of his discussion of carbunculus, an error noted long ago by Beckmann and by others before him. The use of the anthrakion of Orchomenos for making mirrors also shows that it was probably not garnet, for the latter, even when polished, is not distinguished by a high reflective power, nor is it ordinarily obtainable in pieces sufficiently large for such a purpose. Lenz concluded that this anthrakion was obsidian, and though he gave no reason for his identification, it is possibly correct. For Pliny speaks of a mirror of obsidian, as though it were not uncommon, and mentions immediately afterwards that obsidian was used by many for jewelry. When properly polished, this glassy rock yields a better reflective surface than any other dark stone, and the possibility that the ancients used obsidian for mirrors is supported by Beckmann, who remarks, the image reflected from a box made of it, which I have in my possession, is like a shadow or a silhouette. But with this difference that one sees not only the contour, but also the whole figure distinctly, though the colors are darkened. It is likely, however, that the obsidian mirrors of antiquity, being greatly inferior to those made of metal, were for ornament rather than utility. Against the identification advanced by Lenz, it can be said that Theophrastus has already assigned another name, Liparian stone, to obsidian says 14, but this may have been only a local name for the stone. Also, the anthrakion of Orchomenos may have been a darker variety of obsidian than Liparian stone, perhaps approaching pitchstone in density of color, and was possibly for this reason given a distinctive name. Of course, it is entirely possible that anthrakion was not obsidian at all, but some other dark or black stone that could be given a high polish. Theophrastus on Stones.
few attempts have been made to identify the stones from Troezen and Corinth, which also came from the Peloponnesus. One suggestion is that they were varieties of Anthracea and therefore inferior kinds of garnet. Neither the general sense of the passage, nor the remarks on the appearance of the stones support this interpretation, which may also be due to the careless quotation of Pliny. It seems far more likely that the stones from Troezen and Corinth were not Anthracea at all, but some other stones of attractive appearance. From the imperfect descriptions given by Theophrastus, it is difficult to determine specifically what the stones were, but probably they were certain kinds of variegated quartz, such as colored jaspers, which are not uncommon in the general region around these two places. 34. The remarkable ones are rare, and come from a few places. Hill in his translation assumes that Theophrastus is speaking here of places from which the more valuable kinds of garnets were obtained, but he seems to have misunderstood the real meaning of this section as well as the preceding one. Actually, Theophrastus is simply mentioning certain important foreign localities from which the more valuable kinds of precious stones were obtained. 34. Syene near the city of Elephantine. Syene was situated on the east bank of the Nile just below the first cataract. The site is now occupied by the town of Aswan. Elephantine was a city directly opposite on the southern end of the island of the same name, though this district was known as the source of an inexhaustible supply of building stone, principally granite. There is no evidence that precious stones were ever found in the immediate vicinity of the two cities. Therefore, it would appear that Theophrastus is speaking of these places only as exporting points for precious stones that were found elsewhere in the country. Carthage and Massalia, mentioned just previously, are apparently referred to in the same way. 34. Zepho. The name Vato, which is used here as a genitive, is not found elsewhere. Salmasius suggested as an emendation, and Hill adopted this but printed it incorrectly as Sebo is a place mentioned by Strabo in his description of Ethiopia as a large lake containing a populous island. Here the word appears in the nominative as Psibo. The modern name is Lake Tana, and the large island in it is called Deck Island. Possibly in ancient times this island or certain surrounding territory took the name of the lake, and it is to one or both of these that Theophrastus makes reference. 35. Bactriana. An alternative translation is Bactria, the more usual name for this extensive ancient country. Though its boundaries are not entirely certain, it lay north of the Hindu Kush range, and most of it was between this mountain range and the Oxus River. Previous commentators have generally assumed that these stones collected for mosaics were smaragdoi. Though it is true that smaragdos is mentioned in the first sentence of this section, they probably made this assumption because Pliny says the smaragdus of Bactriana was found in essentially the same manner as the stones that are mentioned here. However, Pliny appears to have obtained his information from this very passage in Theophrastus, and in making his own version he introduced this mistake in identification. Pliny made a similar mistake when he supposed that the stones mentioned in section 33 of this treatise were varieties of the carbunculus. Clear evidence that he often misinterpreted the Greek of Theophrastus, or at least sometimes distorted his quotations, is contained in Book Greek Science, section 156 of the Nader C. de History, where, after naming his authority, he gives a quite inaccurate version of a passage in the history of plants. Bailey discusses this particular case in detail. Apart from this statement of Pliny, which is found to be wrong, there is no reason for supposing that these stones found in the desert were smaragdoi. There is nothing inherently improbable about the way in which the stones are said to have been found, since the sorting action of the wind in blowing away lighter sand particles would tend to leave behind the large grains and pebbles. It is probable that the fragmentary rock material collected in this manner consisted of different kinds of colored quartz. 36. Among choice stones there is also the one called the pearl. The high value placed upon pearls by the ancients is evident from the statements of all early authors who touch on the subject. Pliny, for example, begins his elaborate account of the pearl 247 by saying that it holds the highest position among all objects of value, though in another place, 248, he ranks it second among the precious stones. The adjective siapaves has been translated as translucent, since transparent, the usual meaning, is not appropriate to the pearl. Salmasius thought that the negative ov should be added so that the meaning would be not transparent. Hill accepted this reading, but Wimmer did not. It does not seem necessary to change the text. The 8 Greek words in brackets n, epsilon, mu, epsilon, gamma, theta, are not in the manuscripts or in Aldus, but were taken by Schneider from the text of Athenaeus' Theory, 93, where they are attributed to Theophrastus. 36. Pinna. This name is now assigned to a genus of large bivalve mollusks which inhabit warm seas. The species common in the Mediterranean, to which Theophrastus is probably referring, was the first that was known, and so became the type for the genus. The Mediterranean pinna attains a length of about 2 feet. Darcy Thompson includes it in his list of Greek fishes under Pivi or Neva Latin pinna or perna, but he does not give an English name for it. He says that it is a pre-Hellenic word. 36. It is produced in India and certain islands in the Red Sea. Pearl fisheries are still operated today in the Red Sea, the Persian Gulf, and along the coasts of India. In Herodotus, the Red Sea Apulpi Balamdawa meant the Indian Ocean, in which the Arabian Gulf, Apasios Odos, now known as the Red Sea, was sometimes included. Later the term was also used for the Persian Gulf, e.g. in Diodorus' 2:11, and probably that is the meaning. Here, 37. But there are some others. In this section Theophrastus mentions certain dull opaque ornamental stones. Sapphirus has already been listed twice SCC as 8 and 23 along with valuable stones, but the closing sentence of section 36 indicates that the other materials mentioned in this present section were rather common and not highly valued. 37. Fossil ivory, which is variegated with white and dark markings. Though opuros really means dug up rather than fossil in the usual modern sense, it would seem that both meanings are equally applicable in this case, for the material was apparently derived from the tusks, teeth, or, less probably, the bones of fossil animals. Possibly this even refers to ivory in the strict sense of the term, for the story of Pliny about elephants burying their tusks seems to imply that the ancients recovered some ivory from the ground, though it is more likely that they dug up the tusks of mammoths and mastodons, and that this was the real basis of Pliny's statement. Even in modern times, a considerable amount of so-called ivory has been obtained from such fossil remains, particularly in Russia. The allusion to the mottled dark and white appearance of the material is readily understandable, since fossil tusks or teeth are often partly discolored by mineral or organic matter. Hill pointed out that the word mulam dav in this passage does not necessarily mean black, which is its most common meaning, for the same word is used immediately afterwards with reference to sapphirus, where the meaning is clearly dark in the sense of dark blue. He therefore suggested that the meaning in this passage might also be dark blue, and that the so-called fossil ivory of Theophrastus was a substance of mottled blue and white color, not really ivory at all, but the mineral known as turquoise. Some later authors, e.g. Lenz and Bailey, have accepted this suggestion and have attempted to improve upon it by proposing that the material in question was not true turquoise, which is often light blue or green, but false turquoise or odontolite, which consists of fossil bones colored blue by vivianite, a hydrated iron phosphate. However, since all these identifications are based on the assumption that the material which Theophrastus calls fossil ivory was partly blue in color, they must be considered as little better than conjectures. As evidence against them, it should be noted that Pliny discusses turquoise and fossil ivory in separate places, and when he mentions fossil ivory, he directly quotes this passage of Theophrastus and other passages about bones found in the earth and bony stones, most of which were clearly fossil remains. Though Theophrastus classifies fossil ivory as a stone, it does not follow that the identification that has been suggested is wrong, since elsewhere in the treatise he classifies amber and coral, also of organic origin. In the same way. 37. Sapphirus. It is certain that the less than pi or sapphirus of the ancients was not the same stone as the transparent blue gem now called the sapphire. Theophrastus lists it here with other opaque minerals, and by comparing it with the phaeanos implies that it was dark blue in color. Pliny, though apparently following Theophrastus in part, specifically states that it was blue and never transparent. The statement of Theophrastus in section 23 that sapphirus seems to be spotted with gold is especially important for its identification. Pliny states in one passage that eastern sapphirus was a stone in which gold sparkles, and in a second passage that it was refulgent with spots like gold. And in a third passage too, he compares it with another stone that was covered with drops of commentary, gold. Dionysius Perigex also confirms these descriptions, which can only apply to dark blue lapis lazuli containing disseminated specks of iron pyrites. Owing to their appearance, these were naturally mistaken for gold by the ancients. This variety of the mineral is by no means rare. Lapis lazuli of solid color, or at least the kind that did not contain conspicuous amounts of pyrite, was given the name Llanos, as is explained in the notes on section 31. Pliny remarks that sapphirus was not suitable for engraving when intersected with hard particles, and it is quite probable that because of the presence of pyrite, and possibly other hard crystalline minerals, the stone was rarely engraved but was simply used as a plain ornamental stone. Examples of ancient lapis lazuli speckled with iron pyrites have been found, and it is reported that an ancient imitation made of blue glass containing grains of gold has even come to light. 37. Procetus. The quantity of the middle vowel of pi is uncertain. The Eldine text has pi, and this accent was accepted by Wimmer. In this same passage, mu also appears as mu. However, in the lexicon of Liddell Scott Jones, both nouns appear with a long middle vowel like others of the same termination. That Procetus was a green stone of some kind is clear both from its name and from the remark that Theophrastus makes about its color. The name was apparently derived from pi, a leek, and so pi was probably a stone having a leek green, dull, dark green color. Theophrastus actually says that it was rusty in color, but this must refer not to iron rust but to the patina of bronze or copper rendered in the translation as verdigris. In previous attempts to identify the stone, commentators generally have supposed that it was one of the various transparent or translucent greenstones. Hill, for example, thought it was root of emerald, referring probably to praise Lenz identified it as bluish-green fluorite, and Stephanides suggested that it was beryl or chrysoberyl. That any of these identifications is correct seems very unlikely, for both the immediate context and the general content of the section show that Theophrastus is speaking of an opaque green stone. Though it is reasonably certain that Procetus was green and opaque, the lack of detailed description makes its specific identification almost impossible. Possibly it was the same as the Precious of Pliny, who listed as a common stone, one variety of which was evidently the same as our heliotrope, a kind of dark green chalcedony or jasper marked with spots of red jasper. The statement about its color in the present passage tends to show that Procetus was green jasper, though the possibility still remains that it was serpentine or some other common green opaque stone. Like many other ancient mineral names, Paracelsus may have been a generic term and may therefore have denoted any dark green opaque stone. Cylinders, seals, and various objects made of green jasper and other kinds of green opaque stone were in use in the Aegean region from early times, as is clear from the numerous finds that have been made. 37. Hematitis. All previous commentators have identified this as hematite, native ferric oxide. Apparently they assumed that it was the same as the hematites of Pliny, a term which certainly included most varieties of the mineral now called hematite. However, Pliny also mentions a precious stone called hematitis, and it seems more logical to suppose that Amurius corresponded to this, for Theophrastus is clearly referring to a mineral substance of this kind. Furthermore, Theophrastus describes it in accordance with its name as having the color of dried blood. And Pliny also states that hematitis was blood red in color, but these descriptions do not apply to the kinds of hematite that are hard enough for use as ornamental stones, since these varieties of the mineral are black, steel, gray, or at the most a dark brownish red inclining to black. Only the streak that appears in these varieties and the soft compact kinds of hematite exhibit the pronounced red color from which its name was derived. Since Theophrastus is speaking here of an opaque stone, hematitis could not have been any of the transparent or translucent red stones such as garnet or carnelian, though the practical certainty that these were always known by other names is itself sufficient warrant for rejecting them. The only common red opaque stone extensively used by the ancients was red jasper, an impure form of silica colored by ferric oxide, and it seems very probable that this was the hematitis of Theophrastus. The allusion to its dull texture agrees well with the suggested identification, though it is probable that other stones of the same general appearance, such as red felsite, would have been given the same name by the ancients. Pliny names Africa as a locality for hematitis and mentions its various uses as an amulet, all of which tends to support the identification here advanced. For red jasper is of common occurrence in northern Africa, and it is known that the Egyptians obtained it locally and frequently used it for amulets and ornamental purposes. 37. Xanthi. Though different in color, this stone was probably dull and opaque like the hematitis, since the close relationship between the two stones implies that they were similar. Pliny names Xuthos as a stone of the same class as his hematitis, and it is almost certain that Xuthos is the Latin equivalent, probably corrupt of, for Pliny seems on the whole to be following the statements that Theophrastus makes here. Since hematitis was probably red jasper, it seems very probable that xanthi was yellow jasper. These two varieties of jasper are similar in all respects except color. Even the color is due to iron oxide in both stones, but the difference is that in yellow jasper the oxide is in the hydrated form. Furthermore, red jasper and yellow jasper are often found together, sometimes in the same small piece. And this mode of occurrence probably explains why the close relationship between these two kinds of impure quartz was early recognized. Numerous ancient objects of yellow jasper have been found, and since it appears to have been the only opaque yellow stone extensively used in antiquity, there is strong support for the identification given here. Yellow jasper was easily available to the peoples of the Mediterranean region. In particular, Lucas mentions Sicily and the vicinity of Smyrna in Asia Minor as localities for this stone. 38. Coral. The spelling Kupatov, which appears in the text, is a variant of the more usual Kopatov. In all probability, Theophrastus is referring here to the precious red coral, Corallium nobile, a species almost entirely confined to the Mediterranean. Both Dioscorides is 275, and Pliny clearly describe its characteristic form and color. It is this variety of coral which has been the most important commercially since very early times, owing to its striking color, luster, and fine texture. Red coral occurs frequently along the coasts and around the islands of the Mediterranean, and although the most important fisheries are now located off the African coast, it is still gathered in various areas along the northern side. The important localities are the coast of Provence around Corsica and Sardinia and in the vicinity of Naples and Genoa. In ancient times, the northern localities were perhaps the only ones known, but Dioscorides mentions the promontory of Pacanus near Syracuse as the most important. This was the southernmost cape of Sicily, now known as Capo di Passaro. Pliny mentions various other localities, most of them around Italy. The manufacture of articles of red coral has for centuries been centered in Italy, particularly at Rome, Naples, and Genoa, and this is still true at the present day. There is little literary evidence that the Greeks used coral to any extent for jewelry or other ornamental purposes, since recent excavations of the sites of ancient Greek cities have yielded no coral ornaments. 270 is likely that they did not value the material for such purposes. However, there is abundant evidence that commentary. It was highly prized as an ornament by various Oriental peoples in ancient times, and that it was extensively exported from the Mediterranean region as an important article of commerce. Coral appears to have been used by the Greeks and Romans mainly for medicinal purposes. This belief in the special curative value of coral lasted well into modern times, for it was included in standard lists of drugs and in works on therapeutics as late as the last century. Red coral has long been supposed to possess magical properties. It was therefore worn as an amulet in ancient times, especially by children, and this practice has by no means disappeared today. Apparently, Theophrastus was not sure whether coral should be classified as a stone or as a plant. Pliny, on the other hand, was doubtful whether to classify it as a plant or as an animal, for though his descriptions lead one to suppose that he considered it to be a plant. His chapter on coral is included in his book on sea animals and the remedies derived from them. This illustrates the difficulty that naturalists have had until recent times in classifying coral. In his notes on this passage, Hill reflects the confusion that existed in his day when he says, "The nature and origin of coral has been as much contested as any one point in natural knowledge. The moderns can neither agree with the Antients about it, nor with one another. And there are at this time, among the men of eminence in these studies, some who will have it to be of the vegetable, others of the mineral, and others of the animal kingdom." Hill's own conclusion, which he defends at length, was that coral is a plant, and he roundly criticizes those who think otherwise. But he changed his mind in his second edition, where he says it belongs to the animal kingdom. The animal nature of most of the corals was not understood until after the middle of the 18th century. 282, 38, and in a way the petrified Indian reed is not very different in its nature from coral. But this is a subject for another inquiry. Indian reed itself, Ivdikos kalamdamuosis, which is described by Theophrastus in his History of Plants, appears to have been a species of bamboo. The meaning of the term petrified Indian reed is very uncertain. The allusion may be to bamboo or some other reed encrusted with calcareous sinter, or to a true plant fossil. Among the works ascribed to Theophrastus by Diogenes Laertius is a treatise on petrifactions in 2 books. This lost work probably contained a systematic treatment of fossils as distinct from ordinary stones and minerals. The final sentence of this section may be an indication that this work was written after the treatise on stones. 39. Some of these contain gold and silver at the same time, but only the silver can be seen clearly. Such sulfide minerals as pyrite and galena often contain small amounts of gold and silver as impurities, and galena, which itself is silver-colored, is the chief modern source of silver. Since galena was also the source of the silver at the famous Laurian mines in Attica, it seems very likely that Theophrastus is alluding to it here. There is ample evidence that the citizens of Athens were familiar with the operations at these mines, and it is improbable that a philosopher like Theophrastus, with his special interest in scientific matters, would have had no technical information about the minerals and the processes used at the mines, especially since there was renewed activity in silver mining at Laurian 285 during the latter half of the 4th century, when this treatise was written. The metallic appearance of certain natural sulfides is noted by both Dioscorides and Pliny, though specific names are given by these authors to some natural sulfides that resemble metals in appearance. There is no evidence that a special name was given to any of these minerals at the time of Theophrastus. 39. They are rather heavy in weight and have a strong odor. The sulfides are distinguished as minerals by their moderately high specific gravity. The mention of odor also indicates that sulfide minerals are meant. Though the pure minerals are odorless on oxidation, they easily give rise to sulfur dioxide, and this has a characteristic odor which is sharp and disagreeable. The strong odor that arose from heating sulfide minerals was certainly well known to the ancients, as the operation must have been frequently performed in mining districts. At Laurian, for example, it is very probable that galena was roasted on a large scale as a preliminary step in the reduction of the ore. Furthermore, certain natural sulfides, such as marcasite, yield traces of sulfur dioxide and hydrogen sulfide when they are exposed to the weather, and their odors become strong when the minerals are broken. Both Dioscorides and Pliny allude to the disagreeable odor of certain partially decomposed sulfide minerals. 39. There is also natural kyanos, which contains chrysocolla. Theophrastus has just mentioned certain minerals or ores that resemble metals. He now proceeds in a characteristic way to mention certain ores that are unlike metals in appearance. From the notes on section 26, it will be seen that expua was a name used by Theophrastus for any bright green copper mineral of an earthy nature. In this passage, when he speaks of a blue mineral that contains a green copper mineral, the association of the two helps to fix the identity of both, since the only 2 ore minerals of these colors that are combined in this way are azurite, a dark blue basic copper carbonate, and malachite, a bright green basic copper carbonate. These 2 are very commonly found together, often intermingled or superimposed on each other. Forms are also known that contain an inner core of malachite surrounded by azurite. Beautiful specimens of intermingled azurite and malachite have been found at Laurian. Malachite is the more abundant mineral of the 2 and is often found alone, with or without the associated azurite. It was almost certainly the most important source of copper in antiquity. It should be especially noted that Theophrastus, in speaking here of native or natural kyanos greater than, means a particular mineral. For information on the various natural and artificial products that were included under the general name kyanos, see the notes on section 55. 39. There is another stone which is like glowing coals, in color. The Greek is ambiguous here, since the word can refer either to charcoal, presumably in the form of glowing coals, or to a red precious stone. This red ore or mineral was probably cuprite, native cuprous oxide, which may be deep red or nearly black in color. So far as color is concerned, the allusion might be to parargyrite, otherwise called ruby silver or dark red silver ore, a silver sulfentimonite. However, cuprite is more likely, because in the same passage Theophrastus mentions 2 other ores of copper, both of which are commonly found associated with cuprite. 40. In general, a great many unusual types of such stones are found in mines. Theophrastus evidently knew that a large number of mineral species existed, and the few that he mentions here and in later sections appear to be given mostly as examples of certain classes. The distinctions which he makes about the physical form or properties of mineral substances also appear to be given only as examples. His concluding remark in this section shows that he knew that other distinctions were possible. 41. The Magnesian stone. It is evident from the descriptions given by Pliny and other ancient authors that various minerals of different chemical composition came from localities bearing the name Magnesia, and were named after them. A white kind which Pliny says was somewhat like pumice, and which came from Magnesia in Asia Minor, apparently corresponds to the one that Theophrastus mentions here. Various conjectures have been made about the identity of commentary, this stone. Blumner thought it was magnetite, and Stephanie suggested marcasite, but both identifications are improbable. For Theophrastus is speaking here of a stone that can be worked on the lathe, and the brittleness and hardness of both these minerals would prohibit the use of such a technique, especially with the appliances available to the ancients. Stillman suggested that it might have been marble, dolomite, or gypsum. Though it is not improbable that gypsum in the form of alabaster might be intended, the most likely conjecture was made by Moore, who believed that the Magnesian stone of Theophrastus was a form of talc. This identification best fits the conditions to be fulfilled. It was a soft mineral substance that could be easily turned on a lathe, it was available in large pieces, and it was white and in some way resembled silver. Some varieties of this hydrous magnesium silicate exhibit a characteristic white pearly or silvery luster. The stone mentioned in the next section was probably an impure form of the same mineral. 42. In Sifnos there is a stone of this kind which is dug up about 3 furlongs from the sea. Sifnos is an island in the Aegean Sea northeast of Melos. 3 stades, here translated as furlongs, are equivalent to about 1,820 feet. Pliny is the only other ancient author who describes the stone found on Sifnos, and he appears to have obtained his information about it mainly from the present passage, though he adds that the green stone found at Como, modern Como in northern Italy, was put to the same uses. It seems probable that this stone found on Sifnos was the variety of impure steatite or soapstone called potstone, usually grayish-green to dark green in color, and so soft that vessels of almost any shape can easily be carved from it. Though Fiedler was unable to obtain any evidence that potstone occurred on the island, this does not prove it. Was never present there, since a fairly large local deposit could have been completely worked out by ancient operations. 42. When it is heated in the fire and dipped in oil, it becomes very black and hard, and dishes for the table are made out of it. The blackening of the stone when it is fired and dipped in oil is a phenomenon that is readily understood. If the stone dishes were heated to the proper temperature, and then dipped in a vegetable oil, which probably was the kind employed, black carbonaceous matter caused by the pyrolysis of the oil would be deposited on the surface of the stone, and to some extent in the pores below the surface. A simple experiment was performed which showed how readily this takes place. One end of a green soapstone block 10 centimeters long, 3 centimeters wide, and 1 centimeter thick was heated in a gas flame until it was red hot, and then the entire block was plunged into olive oil. No change of color was observed during the heating, but when the block was plunged into the oil, the heated part became black rapidly, while the relatively cool end of the block simply darkened slightly from absorption of oil by the stone. The blackening was more intense and occurred more rapidly in the place where the stone had reached the highest temperature. When the process had been repeated twice, the color of the part that had been treated became a deep black. Possibly this method of successive treatments was the one actually employed in ancient times, though Theophrastus does not say this. It was also noticed that the blackened stone had a somewhat greater surface hardness than either the untreated stone or the stone treated with oil at room temperature. The results of the experiment show that the statements of Theophrastus are quite accurate in this passage, as they are in other parts of the treatise whenever he seems to speak from his own knowledge. Probably the main purpose of treating the stone with oil was to harden it and make it less porous, though the process may also have improved its appearance. Dishes and other objects made of various kinds of steatite were widely used in ancient times, as is shown by the large numbers that have been found. Black examples are not uncommon, but apparently it is not certain whether their color, commentary, is due to the impure steatite from which they were made, or whether it is the result of use or of some artificial treatment, such as the one that has just been described. 43. Others can be carved with iron, but only with rather blunt tools. In spite of the lacunae in the text, it is easy to understand the paradoxes which Theophrastus mentions in this and most of the following section. He is evidently puzzled by the contrast between the hardness of mineral substances and the ease with which they can be split or broken. Many minerals or rocks cannot be scratched or cut by ordinary iron tools because of their surface hardness, yet because of their low cohesive strength they can be split or chipped easily by blows from a blunt iron tool. However, one might expect a priori that because they are hard, they ought also to resist forces that tend to break them. As is well known, even diamond, the hardest of minerals, can be split with no great difficulty. When one mineral can easily scratch or cut another, the difference in their cohesive strength may sometimes be such that the harder one can be split more readily than the softer one, if the tool is made of a material with a lower surface hardness than either of the minerals. Theophrastus was apparently the first writer to call attention to these matters. It was not until the time of Mohs 1773 to 1839 and other modern mineralogists that difference classifying and identifying minerals. The text in this section is so corrupt that it cannot be amended with certainty, but some interesting emendations suggested by Stephanides and others have been combined to form a possible reconstruction of it. These appear in a footnote referring to section 43 of the translation. 44. The stone with which seals are carved. That this was corundum, native crystalline aluminum oxide, particularly the impure form called emery, is highly probable. The strongest argument for this view is that corundum was the only mineral available to the Greeks that was hard enough for engraving varieties of quartz or other hard stones that were only used for seals, though some have maintained that diamond in the form of splinters or powder was used by the ancients for engraving stones. There is no real evidence to support this. It is very doubtful whether diamonds were even known to the peoples of the Mediterranean region in ancient times. On the other hand, there is definite evidence, both literary and geological, that corundum in the form of emery was available to them and was employed for engraving gems. Dioscorides mentions a stone named mu as the kind used by jewelers for polishing their precious stones, and Hesychius 300 defines this as a kind of sand used for the same purpose. It is from this Greek word that our English word emery is derived. Pliny, however, appears to use adamas as one name for the kind of stone that was employed for engraving gems, for he states that fragments of this were embedded in iron by engravers and used for cutting the hardest substances. And in another place, too, where he seems to be following in part the statements of Theophrastus in this section, he remarks that all precious stones may be cut and polished by the aid of adamas. Though his descriptions of adamas show that the name was a generic one used for various minerals of pronounced hardness, it seems clear that corundum, either in the form of the well-crystallized mineral or in the impure form of emery, was usually meant. The adamas mentioned by Theophrastus in section 19 was probably this same mineral. Possibly Theophrastus does not give a definite name to the stone used for engraving seals because the corundum or emery that was used for this purpose went by so many different names. In another place, Pliny states 304 that the stone of Naxos had long been used for cutting and polishing precious stones, and though there is some confusion about the origin of its name, it is highly probable that it was described in this way because it first came from the island of Naxos in the Aegean Sea. This makes its identification almost certain because the chief mineral product of Naxos has long been a high grade of emery widely used as an abrasive. Later in the same past V 147, 300, mu, 30xxxi, 2030xxxdi. 54 Sage Pliny remarks that stones imported from Armenia afterwards replaced those of Naxos as cutting and polishing stones. But here Pliny has probably misinterpreted what Theophrastus says at the close of this section. 44. Whetstone. Though it is likely that the ancients generally used siliceous stones of various sorts for whetstones, it is possible that massive emery was also used for the purpose. For when Pliny is discussing whetstones used with water, he says that the two best kinds came from Naxos and Armenia, and he then refers to his previous statements about their use for cutting precious stones. Certainly when Theophrastus speaks about the apparent identity of the whetstone and the stone used for engraving seals, he seems to indicate that massive emery was sometimes employed as a whetstone. However, since he had no reliable way of identifying two mineral substances of similar appearance or properties, his statement cannot be taken too seriously. 44. And the best whetstone comes from Armenia. This statement is by no means free from difficulty. Schneider suggested the addition of best to the text, since the article cannot stand alone in this sentence. The sense requires this stone or the whetstone. The use of the feminine shows that Theophrastus is referring to AI whetstones in the previous sentence and not to 6, the stone used for engraving seals. Theophrastus probably did not mean to imply that Armenia was the source of the stone used for engraving seals, for neither corundum nor emery is known to occur as a commercial mineral within the boundaries of ancient Armenia. Though extensive commercial deposits of emery do occur in Asia Minor, these are all far to the west, mostly in the district around Smyrna. 307. It may perhaps be asked why a place as far away as Armenia is named as a source of the whetstone, when suitable whetstones could certainly be obtained from places near the Mediterranean. Pliny names several convenient sources like Theophrastus on Stones, Crete and Mount Tegetus in Laconia, as well as the distant sources like Armenia, Cilicia, and countries beyond the Alps. There is, however, nothing remarkable about whetstones being brought from a distant place like Armenia, since such stones may have been far superior in quality to those brought from nearer places. At the present day, whetstones that have desirable properties and can be obtained only in certain places are often exported to distant markets. 45. The nature of the stone which tests gold is remarkable, for it seems to have the same power as fire, which can test gold too. In this and the two following sections, Theophrastus alludes to the touchstone and its use in testing precious metals. Since these passages contain the earliest account of a method of determining the quantitative composition of an alloy, or indeed of a material of any sort, they are of considerable importance in the history of assaying in particular, and of analytical chemistry in general. The test of gold by fire is also mentioned by a few other ancient writers. Plato 309 apparently alludes to it, and Pliny states that fire was used to test gold, and that the purity of the metal was confirmed if it retained its original color after being heated to redness. He adds that the term obrusa was used as the name for the test. In the Leiden Papyrus the text, the following description of the ancient test by fire is given in recipe 43. Atez tifo r gold d. If you wish to test the purity of gold, remelt it or heat it. If it is pure, it keeps the same color and remains pure like coinage after heating. If it appears whiter, it contains silver. If rougher and harder, it contains copper and tin. If black and soft, it contains lead. 311. Pliny 312 gives details of the fire test as it was applied to silver, and in the Leighton Papyrus text, the fire test for silver is described immediately after the one for gold that has just been quoted. It, 311. XM 127, seems clear from these descriptions that the ancients applied this test in only a qualitative way. It could also have been used for rough quantitative measurements, since a similar procedure was once used in the French mints to estimate the composition of silver alloys. And a somewhat similar method was used to estimate the percentage of copper in gold alloys in the old mints of Japan. Possibly the ancients also used the fire test for rough assaying, though the available evidence certainly gives us no grounds for believing this. It is very unlikely, as some have conjectured, that in testing gold by fire, they ever employed anything like the accurate modern method of fire assaying in which the gold is isolated by the fusion of a weighed sample of metal. With chemical reagents, the silver is removed from the gold by acid treatment after this fusion, and finally the pure metal is carefully weighed. 45. The stone worked by friction. When gold or gold alloys are tested by being rubbed on a touchstone, a plainly visible streak of metal remains on the black surface of the stone. The intensity of the yellow color of this streak is directly related to the gold content of the metal. In modern practice, streaks made by gold alloys of known composition are placed alongside a streak made by the metal that is being tested. This is done with touch needles, which are a graded series of heavy flat needles tipped with gold alloys. The color of the streak left by the metal is then compared with the colors of the standard streaks, and a match in color indicates that the metal has the same gold content as the corresponding standard alloy. In the modern use of the touchstone, the streaks left by the standard alloys and the unknown metal are nearly always tested by means of chemical reagents. With this refinement, the method becomes more delicate and more reliable. There is no mention in ancient literature of the use of touch needles or of standard alloys in any form, but unless standards of some sort had been used, the method would have produced only rough results. However, the statements of Theophrastus in the next section and those made by Pliny show clearly that the ancients achieved results in the use of the touchstone that approached in delicacy those obtained at the present time. Since the references made by ancient authors to the touchstone and its uses show that they had no direct knowledge of the method of performing the test, it is not surprising that no mention is made by them of any standards of comparison. It is very improbable that the ancients made this method of assaying more reliable by the use of chemical reagents, since the principal reagents that are necessary, namely nitric acid and aqua regia, were almost certainly unknown to them. It is of considerable interest to note that the method of testing gold and gold alloys by the touchstone is still very widely used at the present time, especially by jewelers and by dealers in scrap gold. Silver and silver alloys may also be tested by the touchstone, though the method is less suitable for silver than for gold. Theophrastus shows in the next section that the ancients did use the touchstone for testing silver, although it was also used in early modern times for assaying the alloys of silver and copper, as is shown by the detailed descriptions of the process in various early works on assaying. 817. The method is no longer employed for the quantitative testing of silver alloys. It is still used, however, by jewelers and by dealers in precious metals to detect silver in various alloys, and appropriate reagents are applied to the streak left on the stone by the alloy of unknown composition. In the earlier use of the touchstone for assaying alloys of silver and copper, graded touch needles composed of alloys of silver and copper were employed, and the streak left on the stone by the unknown alloy was compared with those left by the standard alloys. 46. They say that a much better stone has now been found than the one used before, for this not only detects purified gold, but also gold and silver that are alloyed with copper, and it shows how much is mixed in each stater. Probably the touchstone was first used only in a qualitative way, to distinguish fine gold and silver from their alloys, but when the technique of performing the test was improved and, as Theophrastus says here, a better kind of stone was discovered, this test was later developed into a method for determining the proportions of the precious metals in alloys. Though Theophrastus does not say so, the touchstone was undoubtedly used by the ancients to determine the proportions of gold and silver in their alloys. Pliny discusses the different proportions of silver in native gold found in different places, and this information probably originated from assays made with the touchstone. Moreover, since early Greek coins made of gold, silver, or electrum show relationships of weight and value, it is clear that a method of assaying gold and silver alloys must have been known even before the time of Theophrastus. Probably the refined or purified gold mentioned in this passage should be understood to include not only fine gold but also the alloys of gold combined with silver, especially those of high gold content. The analyses that have been made of ancient gold objects show that even the best ancient gold contained a sensible proportion of silver, and much of it contained a considerable proportion. The invariable presence of silver in their gold seems to have been recognized by the ancients, for Pliny 319 remarks that all gold contains silver. The statement of Theophrastus may therefore be interpreted to include the use of the touchstone for assaying the alloys of gold combined with silver. The importance of this passage as evidence that the stater was the real standard of reference in the Greek system of weights has been pointed out by Professor Ridgway. 46. Indications are obtained from the smallest possible weight. The smallest is the crive, and after that there is the kolibos, and then the quarter obol or the half obol, and From these weights, the precise proportion is determined. The smallest proportion of metal that can be detected by the touchstone varies considerably and depends chiefly on the skill of the operator, the kind of alloy that is being tested, and the relative proportions of the metals in it. Though Theophrastus evidently names in ascending order the amounts that can be detected in a sample of alloy weighing a stater, he does not give any precise information about the relative values of these weights. It is possible, however, to deduce both their relative values and their actual values in terms of modern weight units. The name of the second weight was also used for a small bronze coin, and the names of the third and fourth were used for two small silver coins, the quarter obol and the half obol. Since the stater, which is taken as the standard, was also the name of a silver coin, it seems reasonable to conclude that these weights were the same as those of the coins bearing the same names. The Attic silver obol weighed about 0.72 of a gram, so that the largest weight was equal to about 0.36 of a gram, and the second largest to about 0.18 of a gram. The smallest weight, the NAA, literally the barleycorn, probably weighed about 0.06 of a gram, since in ancient systems of weights, the smallest denomination was actually the average weight of certain seeds. And it can be shown by experiment that the barleycorn weighs on the average about 0.06 of a gram. The present English Troy grain that weighs about 0.065 degrees Fahrenheit a gram appears to have been originally based on the weight of the barleycorn. The relative value of the second weight named by Theophrastus and its equivalent in modern units cannot be deduced with equal certainty. According to some authorities, 828 on ancient weights and measures, the K plybos was perhaps equal to 1/32 of an obol, but this valuation gives it a weight of only about 0.02 of a gram, which, in terms of silver at least, is below the weight of the smallest denomination, the K fifth. Since Theophrastus evidently lists the four weights in ascending order of magnitude, this weight seems inherently impossible for the olibos, unless indeed Theophrastus is using the word writhe in a purely figurative sense to denote an exceedingly minute quantity. This seems very unlikely, however, since all the other denominations are clearly to be taken as real weights. Furthermore, it is highly improbable that Theophrastus would have mentioned a weight equal to only 1/32 of an obol or 1/384 of a stater when he was discussing the touchstone method of assaying, because such a small difference in weight, if the stater were taken as the standard, would have been impossible to detect by this method. Actually, the evidence for placing the oliballs at 1/32 of an obol is outweighed by the contrary evidence furnished by this passage. As Ridgway 3 has pointed out, the lollybos must have been a weight between the writhe and the tetromorion, and probably had some simple relation to both these weights. Ridgway concluded from a passage in Aristophanes, from a definition of Hesychius, and from numismatic considerations that the klybos must have been equal to 1/8 of an obol. And it seems likely that this conclusion is correct.